Welcome, everybody. Tonight is the 22nd of February in Dallas. This is Dallas Personal Robotics Group Robot Builders Night online. And we're just going to do the usual thing and roll around the table and talk about our various projects and questions related to building robots or software or the weather or whatever strikes your fancy. So we have the order so far of Pat, then Ray, then Chris, then a free-for-all. So Pat, what do you have?
So I have a hot off the press video I'd like to share, and then I've got some questions. I got a couple of videos, and then I'd like to share a plot, and then ask some questions.
That sounds really promising.
Share. So can everybody see my screen?
Yep.
Or portions of?
Over and over again.
Over and over again, yes. So here's a video of the robot taken today, this morning, and heading down the hallway. So it's going 300 centimeters, so about 10 feet. So you can see it's pulling a little wee bit to the right.
Wait, is that 3,000 centimeters?
That's 3,000 millimeters.
300 centimeters is a third of a meter. No, oh, okay, I got you. Yeah.
It's about a foot, so.
I know, metric units are hard.
30 is about a foot, right?
Not for some of us, but for others it's hard.
If you can move a decimal point, you can do metric.
Yeah, so 3 meters.
So
Let's
there's
say the units are
video.
It's the conversions that are the problem, though, not the
exactly.
us spoiled people with our one language and one unit system. I mean, what a mess.
I still go back and forth miles an hour, and
but in the picture it went back to the same spot it started off wise.
Pretty close. But here's the next
really
run.
Look closely at the towel that it started off on, but it looked like it was on the diamond. Okay, a little off. Okay.
Yeah, it was a little bit off. So here's the next run. So same thing, going out 10 feet.
A little bit of a wobble.
Yeah.
A little bit of a
it's
wobble.
Getting closer to the right side versus the left.
Yeah, it always seems to go to the right, and you'll see that a lot as it goes, because I cut the video out to go kill my program.
I'm looking at the roughly every 2 feet or so towel mark that you have in your design.
So I have no sensors on this right now except motors and encoders. So you can see it's coming back, and it's heading towards the wall.
Just for our benefit, could you let us know, is that actual tile with like grout divots in it, or is it a smooth surface?
It's got grout divots.
Okay, so that, like, I see your caster, like, it kind of fishtails up the thing. Do you think that could be like inching it, just kind of edging it over every time? Like,
okay, so you saw the video where the I'll put it back up, and where we hit the end. I'll go a little farther. So basically, just before I stopped it, I'm going to hit the wall. I'm going to hit the corner here. So I stopped the robot and fixed that. So I took the data I had from that running. So there's the plot. So I start on the left side, and the robot runs along, goes all the way to the end, turns around, and comes back. So if you're looking at the plot, it's a fairly straight line. I'm well within half a centimeter the whole trip.
Wow.
But obviously, if I curve to the right and then I come back and I'm curving to the right again, I'm definitely not driving straight.
So what does the plot represent? Does it represent the position that your robot thinks it's in?
It
or
pre-
actual ground truth.
this is what it thinks it's in.
Yeah,
So when I
which,
look at
which
it,
doesn't represent reality, right? That's what you're seeing. It always thinks it's, I mean, same with mine, right? It always thinks I'm in the exactly where I want to be, but it doesn't mean it's actually there, right? Because odometry has its limitations.
yeah. So what I'm thinking right now is because it's very non-repeatable. Is what I'm thinking is that I am I've got mechanical slippage is what I'm thinking.
Could your two wheels be slightly different diameters? Because your encoders are going to say you went a certain distance, but if your wheels are just slightly different in diameter,
I would think that that would be the case, but then I would always be pulling to the one side and always the same way. And it's not. So sometimes it'll go out and come back fairly straight like it did in the first video. Other times it'll be off. So
I think
Yeah.
you need a smoother surface.
oh well, hang on. Let me redo my house.
Are you?
We had
using-
Chris redo his, so it's only right.
Unfortunately, irregular surfaces tend to give you random readings.
Yeah.
Yeah.
So one of the problems I think I have is I have some 8mm shafts supporting the wheel, and I have 8mm to 1/2 inch collets, a router collet to hold onto the wheel, to the hub. And I think I've got slippage in there, and I think that's part of my problem.
Now,
yeah, you might.
for turn, are you using IMU for heading, or remind me, or we're not using IMU?
I'm not using IMU.
Okay, so that's your heading's gonna be messed up. I mean, and your wheels, what's the width of each wheel?
The width? Oh God,
Yeah.
they're
The tire, right? The tire.
yeah, they're approximately 2 inches.
Well, so you talking? Yeah, I. So they're not
The two-
diameter of the wheel, but the footprint.
Yeah.
The
2
big
inches
wheels.
wide by 6 1/8 tall.
Okay,
It's
so
not a Romy.
yeah,
No.
no, because here's the thing, right? What is your wheelbase? You don't know. You got a wheel that's this wide and another wheel that's this wide. Where are the wheels are touching the ground? You don't know. I mean, if you Google around, I mean, people like really do odometry super well, they have wheels that are razor thin, right?
Yeah.
Because then you know exactly where they're touching the ground and what the wheelbase is. If you have wheels that are this wide, what's your wheelbase? Center to center? Maybe sometimes.
I've adjusted my center to center on it to try to see if I can get it going one
It's
way.
gonna
or the other way.
fluctuate. It's gonna
Yeah.
fluctuate, especially on your surface. Your heading is gonna be immediately off anytime you turn. The only way to compensate would be with an IMU. You have no chance without an IMU.
That's what I'm looking at, and I have the BNO 55 that Ted gave me, and I was reluctant to rip it off of my outdoor robot to put it on my indoor robot because come either this spring or this fall, if you guys have a contest in the fall, summer or fall, I'm going to need it back on that robot. So I'm trying to get another. And
Yeah, Ron's got those pointy skate wheels. I guess they are, or
Skateboard wheels.
skateboard wheels, or razor.
yeah, I've seen them before. They come to almost a point at the bottom.
Yeah,
Right.
Chris, I guess, Chris, if I understand what you're saying that because the wheel has this width to it, that one part of the drive, it might be on this part of the wheel, the other part, it might be. So actually the wheelbase is changing as it drives along because different parts of the wheel hit the bottom of the wheel.
Yeah, especially when it drives over those grout marks. I mean, you can see it. It's always wiggling that way. Why it's always the same side? Does it always go to the right, Pat?
Always go to the right, no matter what so I tried adjusting my wheel spacing on my in my formula, and I went way out, like almost 3/4 of an inch difference in spacing. That should have made a heck of a difference. And I had approximately for the same thing, always pulling to the right, whether I narrowed my wheelbase or I widened my wheelbase.
So Pat,
Yeah, but different wheel diameter.
I never changed the wheel diameters, just the
Well,
the
you may have-
formula.
you may have a difference in wheel diameters.
Yeah.
Yeah, that's what I was saying. Switch the left and the right and see if it pulls to the left.
Yep,
That's a good
what we do.
suggestion.
Yeah.
Or, pull
Or
out a
just
pair of
start the
calipers.
robot at the other end. Start it at the far end, have it go out and back versus the close end out and back, and then see if it's the same in both directions.
Well, it does on the way
Yeah,
back.
and keep
it's
in
still
mind-
close to the right.
Keep in mind, if you have a difference in wheel diameter, you get a curved trajectory.
Like a
not
long
just
arc,
like a-
yeah.
You know, it'll have a radius of curvature. You could sit down and calculate it. You know, if you take one wheel slightly larger than the other, you'll definitely have a curved trajectory.
You know,
Yeah, yeah,
I know I'm a bit crazy now, but why don't you just pull out a pair of calipers and measure it?
I
Wow.
tried that, but my caliper goes to 6 and a bit, and at 6
Not
and an
enough.
8, I was at the limit of my caliper, and it fit
Got it.
on both wheels.
Got it.
Well,
got
and
it.
the other thing with the squishy wheel, it can be hard to get good measurement.
They're not that squishy.
Oh, okay.
So the key is you want basically a solid reel, preferably print of hard rubber, as small, relatively small diameter.
That
It's,
Because
it's
the
one of
bigger
those.
they are, the more variables you allow into the reel, basically.
Hey,
The wheels
Pat,
are like one of those small moving dollies you buy somewhere for like 40 or 50 bucks. They were originally pneumatic, but I put foam in them. I put some closed cell strips of foam and I lined it all up inside and stiffened them up.
hey, Pat, you can try a string around the outside, get the circumference and see if the circumference is the same.
Yep.
That's what, that'll give you a quick one. But I like Ray's idea of just switching, especially since you're just using a collet, just switching the wheels from left to right.
Yeah.
And if it changes the other, that would
But the
tell
key
you
is,
this.
well,
Wheel
Pat,
related.
how do you solve the problem? It sounds like
Two things that
long-term
you said
solution.
stuck out to me, Pat. One is that you said that the tires, you filled them yourself, so they might be out of balance, causing you wobble. But the other thing was that I wanted to ask you, do you happen to have maybe one motor going one way and the other one motor reversed?
Yes.
So
they-
that
I
can
am
cause
using
power
encoder-
differentials in one side to the other, depending on the motor as well. So
Yeah, but
sometimes
there's
have to
there's
compensate for that.
encoders and a PID loop to match the speeds.
Yeah, that
Mm.
the
But it's
pin,
Okay,
pin should take
as long as
care of
they're
that.
matching.
But is the loop around velocity, or is it around like trying to reach a certain number of ticks?
The loop is around velocity, and then I do a correction in there as well for any uneven velocities between the two wheels, and if as well with the angular velocity in that loop as well as part of the feedback.
But none of that matters here, right? Because at the end of the day, what you're looking at is your robot thinks it's at location 00. In reality, it's at location 55, right? All these feedback loops that you're trying to do to keep things going straight, none of that matters. If you go at an arc, none of it matters, right? If your encoders are giving you good data, right? And if your wheels are, all right, then even if it goes in the curve when you don't want it to, you would still know exactly where you are, right? If your odometry works well, right? Even if you're going at an arc but you're trying to go straight, doesn't matter, right? In the end, you would know, where you are, and where you think you are would match where you actually are. And the fact that there's a mismatch has really more to do with the mechanics and the what
Yeah,
your
the mechanics and the
mechanism is able to
geometry.
deliver in terms of accuracy of odometry, right? It doesn't matter whether you close the feedback loop or not.
Yeah.
Well,
so
the question
Friday,
is,
I'm going to get the collets welded onto the shafts. I'm going to tack weld them onto the end of the shaft, so I know that I won't be slipping there.
have you integrated the difference between the encoders?
But sorry, I missed that. Between the encoders and
Take the sum of the encoders, take the difference between the two, and sum those as you go.
yes,
That should be 0. If it's not 0, then you're turning.
100%. I am doing that. And
Okay.
I've also integrated with that the angular, so that I know that if I call to go 100 or 15 centimeters per second in the forward direction, and an angular velocity of, let's say, 10 centimeters per second, that's involved in that calculation as well. So I know what my expected performance is supposed to be out of the motors, and it'll correct for it.
Yeah.
Okay.
Hey, I've got an idea. If you think you might have a slippage problem in your drivetrain, why not hold the robot statically, fix the tires to the ground, don't let them turn, and then give a command to your motors, to apply some torque and look at your encoder counts and see if you've got that thing held still and you can torque the motors and see some counts happening, you got slippage.
Yeah. So the way I think the slippage is when we hit, in particular, once in a while, the back caster wheel will get caught up a little bit in the grout, and I'll see the robot give a little bit of a jerk in one direction.
Oh, okay. Okay, so you're thinking slippage between the tire and the surface. I was thinking drivetrain slippage.
No, I'm thinking when that happens, I think I'm slipping on a shaft,
Oh, okay.
and that's
that
the
would be
only
a good-
time I think it's slipping a little bit.
Okay, that would be a good reason really to try the stationary robot and see if the motors can twist on those shafts,
Yeah.
with the wheels held still. Oh, well, anyway.
Yeah, Pat, if you can't get hold of a true IMU, sometimes you can get, all you're using for something like this is a gyro. So,
Yeah, so it's a gyro, but I've been looking that up, trying to find, because it's the Z axis on the gyro that I need. And the Z axis is the toughest one on just a gyro accelerometer to get working properly. And that's where something like the BNO 55 does a really good job of
that's the one I would go to if supply would allow you to get it. I guess
Yeah,
have you tried RoboShop? Because the last
So
time I checked, they had some.
So Robot Shop has one coming in. Has one coming in apparently at the end of the month on the 28th.
Oh,
So I've got an email notification on it. If I see it come in, I'll buy it.
did you try Mauser?
No, they had nothing. I tried DigiKey. They had nothing.
And Adafruit?
Adafruit did, but then it was $55, I believe, US.
Oh, okay.
And so by the time I get that here, it's going to be about $80.
Gotcha.
God.
So I'm trying the Canadian route for now. I'm going to try to see if Robot Shop, because it's about $32 Canadian and about $8 or $10 shipping. So that's where I think I need to either or wheel slippage or integrate the IMU into it.
That's pretty cool. That's
I got a question. Do I get a gold star for that?
you were leading us off with a gold star.
Oh yeah.
Way to go.
David Anderson's not here with his gold star tonight, though. But
Oh well.
We'll
give you a
cover
gold
for
star
you.
IOU.
You'll get one on the website.
There
That
you
was-
go.
Totally earned. Totally earned.
So yeah, so I've been scratching my head on that today, and that's where I figured either I've got a mechanical slippage problem, or it's a mechanical geometry problem, or the fact that it's just not quite with the wheel base, and because it's a fairly rounded wheel, it's maybe that's giving me my problem as well. That if I'm not sitting in the same spot all the time.
Yeah, I'd agree with you, Pat. It's either some sort of slippage, and something like a gyro will help you out a lot.
Yeah, so I was looking at the plot is what threw me when I put the plot on tonight or this afternoon, and I saw that hey, it thinks it's going in a straight line. Well, obviously the code is working. It's doing what it thinks it should be doing.
Hey, Pat, I just checked Mauser. They've got 936 in stock.
Really?
Yeah. So,
Let me go check their Canadian website.
okay. But it's the Adafruit and it's $34.95 American.
Sorry, could you mention which IMU is that you're recommending to him to look at?
Well, actually, there's another one down here that's even better. They have, they made a new version of the BNO 055 board with what do they call it? Quick
Quick.
mounts.
Yeah.
Yeah, quick. And that they sell it for $19.95, and they have none.
They have none. So
None. And they don't even have a date. So,
how much was the Adafruit one?
well, okay, both of those are Adafruit. There's, like I say, there's the old style, which you have to use DuPont type leads on. And then there's a new style that has the quick mount and the DuPont style. So that's the one you really want to have because it's half the cost. But
yeah, that's $28 Canadian here,
oh, really?
which is not bad at all.
Yeah.
I have a part number of 4646.
Yeah, that's the more inexpensive one, and it's the same chip and everything. I mean, it's actually a slightly better configuration if you use Quick.
Okay.
Okay.
Because it's
But
quick.
you're not limited to that. You can use the other type.
Okay. But it's on order. There's no
Yeah.
expected March.
Mm-hmm. Yeah. Yeah.
Yes,
But
I
they,
think.
but they do have the one, look up 2472. Or
Yeah,
if you're looking at Mauser part, it'd be 485-2472. That's the one that they got a gazillion of.
Yeah, that's the one I see here now.
Yes, so
48
Doug, someone was asking about that part. It's the Bosch BNO 055, and it's a really good 9 degree of freedom sensor. It does sensor fusion, and it has a really good gyro on it, which several of us have used for getting heading, and it works quite well.
Just gonna go see how much shipping is from them.
Right next door in Worth.
I'm just
It's here.
It's bad.
Yeah. So we're not.
30. It's add 30% to it.
That's $9 roughly. Yeah. Okay. Yeah. It's better than 100.
Yeah, so
Whatever.
I'm showing right now $56
Yeah.
plus tax. I'm assuming on top of that. I may wait the 1 week and see what happens with
Okay. Makes sense.
Robot Shop for $20 less anyway.
Yeah. I can understand that.
So yeah, I think that's what I think I'm going to have to do to try to get it to go fairly straight. And then just to be going down. I don't know how much of this I'm going to need for my indoor robot anyway. It's basically learning for my outdoor bot where I do need to go and follow lines. And
Well, when I started off building robots, I used to do exactly what you've got right now with no IMU. I used to just go odometry because we didn't have any contests that lasted long enough to really make it horrible. But once I started using the IMU, I never went back.
okay,
I mean, inside, outside, it doesn't matter. I'm not going to use just straight odometry anymore. It's so much better. And the program wise, it's as easy. That's like one line of code or something. I mean, it's not a big deal.
Plus, in Can Soccer, if I bumped your platform and your odometry was off, that was the end of the contest for you. So
Yeah, pretty much.
Not that hasn't happened before, but
Yeah.
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 So that's been my week.
cool. Gold star for Pat. Way to go, dude.
Okay.
All right. So we have Ray, then Chris, then anyone want to line up after Chris? Paul, cool. All right, that's good. So Ray, what you got?
Whoops. Okay, let's see if I can shrink that down.
Hey Ray, did you get better internet or something? You've really coming in a lot better than you used to.
Got a new laptop. I think maybe that was it.
Okay, yeah.
Do it.
Yeah, no, my internet is still the same. Okay.
Mine got worse.
No Starlink yet?
What's that?
I'm
No
waiting for
Starlink?
Starlink when you can travel with it.
All right. Made some improvements to the mill. And I made a short video to show. Oh, come on. I can't believe that.
Hey, Ray,
Yeah.
what are we looking? We're looking at a stepper motor onto a gearbox.
Yeah, this
or
is,
is that a
it's a 20-to-1
okay?
planetary head.
All right, that's
And
fine.
I can't believe it. The message for stop sharing is covering the play button on the.
So click hide where it says besides stop sharing to the right, click hide.
Yeah, hide it. Or you can, I think you can move that.
Oh, there you go. Okay, there you go. I have added a 20-to-1 gearhead to the Z-axis. I didn't have enough resolution on the Z. That, just like before where the stepper was connected to a sprocket, it's not connected to a sprocket and drives the Z-axis up and down, via this rod that's used to be have the quill lever in it to pull it up and down. I've got all the electronics mounted on a wooden board in the back of the mill. So these are the three axis drives for X, Y, and Z. That's a 12-volt power supply, and that's a Mega with a Ramps 1.4 board on it. And the kind of the nice feature of the 1.4 is it provides you with a display. And you can plug in an SD card here inside, run programs from it. So, like, for example, I can do this. So say I want to go into jog mode. I want to move an axis. And I want to move X. And I'll put in 10 millimeters. And if I move the knob now, it moves X. That was 10 millimeters in the negative direction. It's 10 millimeters in the positive direction. So that's pretty nice. You can, get back to the main menu. One of the things that you can do is you can load a G-code file from an SD card and run it directly. So this setup can run independent of like a universal G-code sender and with a PC or laptop connected to it. So that to me is a nice feature to have stuff run independent and not have to type a laptop just sending G-codes to a machine like this. Anyway, that is my update.
Ray, are you doing? That's great. Are you doing anything with to handle the bearings? They always tell you that if you're using a drill press, that one of the problems you're running into is that it doesn't have any lateral
support.
Yeah, and they suggest that that's one of the big deals And I'm just curious. I was wondering if they had available, because I know you know things like this, whether they have some of those tapered roller bearings or something that you could replace the original ones with, or one of those. I just wondered if that's available.
Yeah, I haven't looked into that. I'm not going to be cutting, hard steels or anything with it. Probably
Yeah, that's true too.
mostly aluminum. If it's steel, I'll have to, use the big mill to do it. But disadvantage with the big mill is it only has 8K bytes of program storage, and a lot of the files that you get from CAD programs are much longer than that.
Yeah.
It's pretty much, if I want to use the Bridgeport, I can write my own G code files basically from mechanical
Like a programmer. Yeah, like a programmer.
Yeah.
Yeah.
So, but there's some advantages to that, because all milling machines had, more complex G codes. Like you can do things like actually cut an arc that's not millions of little teeny line segments, straight line segments. It's actually an arc. So that's kind of nice, and it takes a whole lot less, because you had back in the mid 80s, it only came with 8K bytes of storage, so you had to fit it into what you had. So and you can, for longer programs, you can page them out so they're 8K blocks, and then you run one, when you're done with that one, load the next, run it. But to me, it's easier to use CAD software to create a part, say this is what I want where, and what the tools are, and what the material is, because it selects feed rates and for you. So that's kind of nice. You don't have to look all that stuff up in charts, and for the most part it's a guess anyway. And then I don't think that one has it. I know the ESP32 or the code that Bart Dring or D-Ring, or however his name is pronounced, he actually had it so you could change the feed rates, the feeds and the speeds. So if you were traversing at say like a G0 code, which is a fast traverse, you could slow that down. You could slow the feed rates down. Feed rates are when you're actually cutting, so they're much slower. But I haven't seen that in this yet, so I don't know if it's a feature I just haven't looked at in the menu.
Yeah, I want to say you can do that with a ramps board.
I thought you could, yeah.
Yeah.
I haven't used it, so it's probably in one of the menu, selections that I.
One last thing, I think I saw chips. Does that mean that you've actually cut something, and what's it look like?
Oh yeah. In fact, that plate that held the stepper and the bearings and sprockets and all that stuff, I actually cut that on there. That was before I added the Z-axis motor, so I was the Z-axis, pulling down on each pass, and it took a long time. I was finished cutting, long before the program finished, so it's like just waiting for it to run out, because it was supposed to cut a hole for the bearing, and then it was supposed to cut a hole for the stepper motor, and if I stopped it, I would have lost my reference. So I had to wait for it to do nothing basically, and then run over to the other hole to cut it. So but yeah, I'm gonna test it with like a 1/2-inch drill to see if it can put the right amount of force on a drill bit, and then
That'd be good.
Yeah. So, and there's I actually have to shorten the Z-axis motor shaft about 1/4 of an inch, because it goes into one of the first sun gears. There's like a collet basically with 2 screws on it that clamp down onto the motor shaft, but its motor shaft is just a little bit too long. So I'm going to figure out a way to grind that off without heating the shaft up too much. And
Well, another thought is you could make a spacer for between the two.
I actually used 2 nuts on the screws. I don't know if you saw that or not, but
Yeah.
2 nuts on 4 of the screws to give me the 1/4 inch difference.
Yeah.
But I'd like to get rid of that if I can. And then,
Yeah. Well, I mean, make yourself a plate and just put it in there.
yeah, I'm assuming I can cut the motor shaft off. I have a cutoff wheel. If I go
Yeah.
slow enough, and
Yeah.
it probably should be okay.
Yeah.
So, but yeah, it's been kind of fun. You know, I can go from CAD drawings to, you know, machining apart. I've got to get better fixturing to, you know, to hold pieces, because they say, you know, that's in a lot of cases that's the thing that fails, is your whatever you're using to hold the piece that you're working on, it's not being held stiff enough, and the bit pulls it out a little, or, you know, the constant you know, as each cutter surface comes around, it, you know, thumps it a little or taps it a little, and that little bit of vibration can loosen it. So because that table's not very big, and so I've got to figure out something there to, you know, improve workpiece fixturing or holding. So
Yeah. Yep.
So, but do you have a small mill, Doug?
Yeah, I do.
Oh, you do?
It's a small CNC. It's a Shoreline.
Oh,
but
sure.
it is.
Okay.
But it is a CNC.
Yep.
So, you know, I don't use it very often because I'll be quite honest, 3D printer kind of like for most of the stuff that I make took care of that. Now, when I want to make something out of aluminum, you know, when I really want it to be nice and not not green and red and purple and brown, because then I got all my different 3D printer filaments, you know, put on at different times. Well, then it would be I can use it.
Yep.
And that one's a little different than yours, but
yep. Ron, do you have a CNC mill?
Yeah, I do. I have a tabletop as a carbide, and let's see, the controller fried, so I made a new controller for it. And where I am right now with it is I have this weird thing where when I run one of my axes, X, Y, or Z, then the spindle fires up for a moment. And the spindle is, I'm still using one of the original, the spindle driver, which it's a 3-phase, whatever, brushless motor controller.
Yeah.
And I think it's driven by analog signal. And somewhere I'm getting a little glitch, enough to spin the spindle a little bit, which wouldn't matter that much, except when I want to take if I want to take the tool over to the little tool sensor or whatever, and get an accurate reading of the tool length or whatever. So that sort of caught me up, and you know, it's like, gee, I have to have a motivation or something I really need to make with this, and I lack the skills, the machining skills. So what I'm sort of up against is the learning curve of doing subtractive machining versus the 3D printing stuff.
Right.
So anyway, so that's kind of, it's moved it back into the shadows, the mill. But maybe I'll have some reason. I did recently get a carbon fiber printer, but I'm just getting started with that. And it looks pretty neat. It's a MakerBot method. And I guess I whined enough to my brother that he was sensitive to that, since that's his business, is tool making and stuff like that.
Oh, okay.
So he felt the need to, originally he was just going to print parts for me. I had a need to run a small run of parts that I was having difficulty with. And I really got it worked out fairly well with ABS. But anyway, so to date, I guess about the only thing I've printed in carbon fiber is a little electrode holder assembly here. And anyway, so I really haven't done much with the printer, but the filament is about $100 a pound.
Wow.
So that's, to me, that's compared to ABS at $10 a pound. It makes it painful to want to
Yeah.
make too many big things out of carbon fiber.
Mm-hmm.
But anyway,
Well, the carbon fiber you're talking about, doesn't that run on most any machine that will run ABS?
I think so. I think the only difference is, if I'm not mistaken, is you just need to have a nozzle that's like stainless or something like that. I think the carbon fiber, and so what this is, I guess, is it's carbon fiber, reinforced nylon. I guess it's little chunks of carbon fiber in nylon. I think MakerBot calls it, I don't know, CF12 or something. And anyway, so I don't really know that much about it. I mean, yeah, so far the part I made is a bit stronger than ABS, and I just need to, I guess, work with it. But yeah, I think any printer with a stainless, or what sometimes do they do ruby also for tips, whatever, then that would get you there. So
I've done carbon fiber, not very much, but I got some carbon fiber and I ran it through my regular our spec 3D printer, and it wasn't any problem.
okay.
You can do ABS as well, because it does have a heated plate.
Okay. Yeah, the only thing on the method is probably overpriced for what it is. It's convenient. It has a heated build chamber, which is nice. And I know people are doing heated build chambers, but so far, and I can't tell you dimensionally, I haven't messed with it that much. But and I guess the other nice upgrade is having a textured bed. That's something that's kind of new. I guess what I'm comparing against is like a MakerBot like 10 years ago. And whatever that plastic, I forget the name of the plastic is. I don't know if that's a common thing now, but the method has like a flexible build plate, and that works really well. I mean, everything sticks to it nicely. I think in the past, like for example, this came off Thingiverse, but I printed this on the method, and in the past, I'd have problems with curling and so forth. But when this printed nice and flat, and no curling at all. So to me, that's a neat feature, and that must be something that's readily available if you have difficulty with things sticking to your build plate.
Yeah.
The thing I would say is that the heated chamber is probably one of the big things.
Yeah, for ABS, I would agree.
Oh, say again?
Heated chamber really helps ABS.
Oh, yeah, you mean as far as the entire part then is kept at temperature, and then it can shrink uniformly or whatever.
I had mine just has an enclosure, and I know that David has an enclosure too, but that helps quite a bit too. I mean, I have identical printers, one that's got an enclosure and one that doesn't. And when I do ABS in an enclosure, everything comes out okay. If I do it in the other thing, I've got all the classic ABS problems.
Oh, yeah. Okay.
Yeah, it'll delaminate if you don't keep it warm.
Mm-hmm.
Oh. So is there another heat source, or is it just heat from the bed?
Well, you have to look at it. Like in mine, the way I have it enclosed, I actually have to open the door part way to keep it at the right temperature, because it'll overheat. But I have no control over it. I mean, I don't, I put it in there and I have a thermometer and I look at it and say, okay, it's cool. And then I go. I don't try to actively control the temperature.
Okay. So about what's your target though, roughly, for ABS when you're printing to keep the change?
I want to say it's right around around 100 or so, if I remember right.
Okay.
It's
not quite. See,
maybe a little less than that, maybe in the 90s.
Yeah, okay.
Yeah, 90s.
I tend to do 110, 105.
No. That's on the bed. But
Yeah,
I'm talking about
I'm talking
about in the area,
Enclosure.
you know, it's
Yeah.
usually around 90.
Yeah, I think the method on ABS, I'm just from memory, whatever. It's been a week since I've used it, or a few days anyway. I'm thinking it runs 80 centigrade for the build chamber.
Yeah.
And it's nice. Yeah, okay. So it temperature control it and all that stuff. But again, I mean, I wouldn't have been able to justify buying the printer. So, but still, it's pretty slick. It's a little noisy though for that much money, and it's heavy. The printer weighs I can barely lift it. I think it weighs about 70 or 80 pounds.
Whoa.
And that makes it tough to handle. I could barely get it out. Pam had to help me lift it out of the box. I hate to say it. It's like, this thing's a beast.
Yeah.
But
Well, that's pretty warm. So that's like 176 Fahrenheit, 80 degrees C.
Yeah.
Yeah.
I guess it's got to be below the melting point of acrylic, right? Because don't you have acrylic walls on your?
I have an acrylic door, but like I say,
Oh, okay.
I'm actually using foam board on the outside. So
Oh, you
that's
are.
where I guess, so I've kind of got an insulated sidewalls,
Yep.
and I don't ever use a full door. I have a full door and I have a half door, and I tend to use the half door, which usually makes the enclosure the right temperature.
So, gentlemen, I don't own a 3D printer, and I've been in the market for one recently, thinking about whether I would want to try to build my own or buy one. I think building would be a nice project, but I'd probably end up with a crappy printer that I'd want to buy one afterwards anyway. So, but the reason why I mentioned it is you guys are talking about heated enclosures, and one of the things I was interested in was printing carbon fiber. And just recently, there was an article that I will try, I think, to share it on the mailing list about a specialized, some real good results that a research group had for printing carbon fiber, but using a heated enclosure. But they made a specialized cooled head, and all the electronics were specialized. So they actually had the enclosure up quite hot, like oven temperature almost.
Mm-hmm.
But and so because there was such a much smoother transition of the carbon fiber to room temperature, they were able to control that cool off period. It didn't delaminate as much, and they were able to use a much higher grade of actual carbon fiber versus filler, whatever plastic filler they use typically.
Mm-hmm.
So it would be worth taking a look at, because I think that's probably the real hot enclosures, probably what you're going to see in later builds.
If that's a similar article to the one I saw, they had put all of the motors and what have you on the outside so that they wouldn't be in the
overheat. Yeah,
that's right. And they had a glycol cool on what they couldn't have. They had coolant running through to keep the other stuff cool.
Wow.
Ron, does yours have the motors and stuff on the outside of the chamber?
You know what? I guess they are. Yes, they have like a bellows that insulates the build chamber from the. I want to say, gosh, I'll go look at it. I guess I should look at it. Hang on, let me.
and in my case, David, no. It's probably, eventually I may degrade my stepper motors, but I don't use it enough. I don't use ABS enough to worry about it.
Well, what I found was you were talking about insulation. What I did was I put a bunch of towels over mine to give it insulation and let it heat.
Mm-hmm.
Well,
worked. If you go out, if you look up Paradug, Paradug, out on Thingiverse, it's one of my things. So I mean, you can see it. It's based off of an IKEA side table. Is the first part, and it just uses that as a frame, and everything's built around it.
An IKEA hack. Cool. Hey, links
Yeah.
are always welcome in the chat.
Yeah. So since Dave was asking, the motors seem to be insulated with a pleated bellows, I think it's almost like a plasticky material. It's the pleated bellows, but it insulates helps insulate or isolate the build chamber from the motors and stuff like that. So anyway.
Cool.
Makes sense.
Yeah, isn't the table called the LAC? Like the lackey, L-A-C-K, I think.
Level, yeah.
I think so. I can't. It's been so long ago. I can't really remember.
No, that's it. It's called a LAC table. I thought of building one for my printer, but it looked a little involved and it wasn't quite what I wanted.
Well, the one I did, John, literally, you can hold all of the parts, the 3D printed parts in your hand. It's very, very minimal. It uses Dollar Tree foam board for 3 walls. I mean, the most expensive thing in it is the IKEA light that I put in it. It's one of those LED strips. But you can look it up. I guess I can do it too.
Yeah, put the link in chat versus let's
Okay.
keep it moving.
But it was really cheap.
I was going to say somewhere on Thingiverse they actually have connections where you could connect the foam bar together to make your bots and that. So yeah,
Oh,
there've
just
been
with foam
several
board?
versions out there. But yeah, the one printer I have, well, is the not off power spec and it's enclosed, so and then the other power spec isn't. But yeah, the temperature I tend to run around 74 unless for the heated bed on the one power spec. So, and then around 230-ish for up on the ABS.
Yeah, I think you and I both got our power specs about the same time. From
Yeah, I actually have two power specs. That's why I have the one that's crudely enclosed knockoff of the original, and then the other power spec is more what is that one called? Anyway, the open version, the one that came later.
Doug, is one of your 3D printers a Milan 150?
Both of them are.
Oh, both of them are. Okay.
Yeah.
Yeah, apparently they don't make the 150.
No, they don't. And I found them to be, they were at the time I bought them both for $150. I mean,
Yeah.
150, and I think one even less than that.
Yeah.
And they were really, for what you got, it was quite a bit. My advice to Ross, if he was going to buy a 3D printer, which I think I would say is the way to go.
I'm all ears.
I would tend to set in that because, in the case of Doug and I both, we built the first 3D printer.
Yeah.
I haven't built one since then. So.
Yeah, for the price of 3D printers, I think you're much better off letting somebody
I
else.
I would never do it with the naivety of thinking I was going to save money. It would be more because I'd want to know exactly how it worked.
Yeah,
and enough that I could hack it later to do something else. But that's just kind of the way I am.
And you want one that works out of the box.
Yeah, because the reason why I really want it is not just a curiosity. It's actually I want to accomplish some building.
Yeah. Now, somebody said, Doug, if you didn't have anything, but you had a really deep wallet, I would say go get a Persa. Okay. Just go get a Persa. Everybody who owns a Persa is happy. We're all happy campers dancing around in a circle. I mean, it's just nobody has problems with a Persa.
The last time I looked, it's about $1,000 and it comes built in the box.
Yeah. And you get a little discount if you build it yourself.
Yeah, you get I've got an MK3S Plus Prusa. It's you get $200 off if you buy it as a kit.
Yeah.
And I only made two mistakes building it, but both were recoverable.
Yeah.
Hmm.
And
Yeah, well, I guess when you say build my own, it would have to be a kit. Like I don't necessarily mean piece
yeah,
together my
well, I'm also saying you can go back I believe they can go back a generation, and they're still great printers, and you can save another couple $100 if I remember right. But
You said nobody has complaints. I actually do have one complaint about mine, and that is it is somewhat static sensitive.
Static sensitive.
Yeah, but
Okay.
there are
Yeah,
kits.
I've got a
there are
Raspberry.
kits.
I've got a Raspberry Pi Zero that I'm using to turn it into a print server, and the Raspberry Pi resets if I'm not careful to ground myself before I touch the frame.
Yeah. Yeah, but there are kits and there are other kits. Because when I think of a kit, mine came from China, and on the bill of lading it said spare parts, and literally there were all things, bits and pieces for everything. The kits that I've seen for the Prusa and a lot of the other people that are calling kits, the base is put together and the top frame is put together, and your kit part is putting the top to the base, and then applying a couple of more things. It's not a true kit that I would call it a kit. It's a partially built. It's a partially built printer.
You're
I
seeing
like
the
how
little-
I get you.
I like how it gives you
the other
spare
way-
screws and parts for everything.
Yeah. The other now, if you just went there and said, "Hey, listen, I just want to see what all this 3D printing stuff's about, and I just want a beginner's experience about it," then I would get a creatively. What's the one? It's the one they sell at
Reality.
Creality, yes, thank you. Their basic machine is now the problem with that machine is it's not going to have the flexibility of the Prusa. It's going to be pretty much a PLA machine. Okay.
I have a Creality
One-
Ender V3,
Yeah.
Ender 2 V3, whatever it is.
Yeah. Or the
And
one
for
V
PLA, it's
150.
been okay.
Yeah.
And
It should be an out of the box experience. I'm sure, Pat, when you put it together and you did your first print, it probably came out.
No. So I had a lot of print problems with my print lifting off the bed. The corners would lift off. And it turned out that I bought a bed leveling kit. So no matter how much I followed the instructions and leveled the bed with a piece of paper and made sure everything was good, I always had problems. I put a bed leveling kit in it for whatever it was, $60. That went away.
Yeah.
so
Well,
I don't know if y'all can see it, but I'm on Micro Center right now. So if you can see the window, this is probably the one I would be picking if I were spending money to buy one right now, because it's enclosed. The company's pretty good. Actually, I have this resin printer from the company. So these are the options though they have out there right now at Micro Center. So you can see, this one's enclosed. As I said, that would probably be the number one. I have this one in a box I haven't put together.
that one there, the Ender 3 Pro, that would have been the one I would recommend as an absolute beginner. I would say that one is it's really just a basic machine. One of the nice things about it is if you go out on Thingiverse or just search the web, there's all sorts of improvements that you can 3D print. So it gives you something you can actually improve your machine while you're learning to use it, which is really nice. And I pretty much did that with my machine. If you look,
And then it's like this one.
if you look at my machine over there in the corner, you can see all the red plastic on it. Those were all things that were added to it. So,
See.
It's going to take a while. But they have one version where it has the all level already built in. So you definitely all level helps. But otherwise, what happens every so often, you have to re-level the bed.
yeah, leveling the bed. Here's the problem, Ross. if you get a flat bed to start with, leveling it is not a big deal. Once you got it level, it'll last for probably 6 months, and then eventually you'll have to adjust it a little bit. It's nothing to be afraid of. The problem you get is if you get a bed that's dished in the middle, or it's bowed in the middle, or it's warped, then you're leveling. No matter what you do, you really have a problem with it. And then that's where you need one of these probes that can essentially map your bed and adjust to where you are on the bed.
And you can add that on
or you can
or
do
wide route like there that has already included.
Yeah.
or you can do like I do, because I have all that stuff. I've enabled mesh bed leveling, which I do
Yeah.
the mesh bed level, which does your mapping just like you're talking about with the piece of paper and the thing and the control knob. I've got it set up for doing 25 points across my bed. And I do that, and you're right, 6-8 months. As long as I don't have to change the glass, which I need to change mine now because Pet G took a chunk out of it. It works great, and that's just still a manual thing. But it usually requires an upgrade to the firmware. But a lot of the firmware these days have that already enabled. You just have to go literally into the control unit and say, let's do some mesh bed leveling.
Yeah. So Ross, if you're in it, like I say, just as a beginner, go get the Ender 3 Pro and get. I believe it comes with a magnetic bed. Made out of, it's like those things. It's like those things that you get these little adverts that are made out of magnetic material. Well, they just have a bed that sits on top of that. And the nice thing about that is you can just let it cool, pick it up, twist it, and it'll pop right off. But that is also limited to pretty much PLA. So, but PLA is very versatile, and unless you're making machine parts that have got really super strength, PLA is pretty fine.
Don't leave it in your car in the Texas in the summer.
Yeah, that's the thing.
But I have PLA all over my robots, and I've never had melted apart because I don't keep them in the car. But you're right. I could melt it.
Anything you got to print that goes outdoors, you want to use PETG. So it won't melt in the heat.
That's definitely a nice material. But you can get away with PLA.
I melt PLA with stepper motors. I have a stepper motor robot that was, I don't know, one of my more later robots. Anyway, hot steppers managed to deform the PLA. So
anyway. And you don't make a fan support out of PLA that you're going to hang over your extruder either, because it's just going to go over time. But if you're just making mounts and that sort of stuff, and like I say, if you've never had a 3D printer, if you're in it for $200, you're never in it for just $200.
That's the starting.
But you're at a lower cost point. And there's enough of those machines out. Like I say, you can make improvements from the web. You can get, and even if you're good at selling used stuff, which I'm not. I know Ron is, but I'm not. You can sell that stuff. You probably still get a half your price off of it when you sell it. So, but if you're deep pocketed, I'd go with the Persa.
If you like to print flexible, and I really like flexible, you need a direct drive extruder.
Really, no, you don't. No, you don't. I'll disagree with that. It's easier. I've got a Bowden tube over here with the thing, and I've got TPU, and I haven't printed it extensively. But all the tires on my ExoMine, my Rover, they were all TPU, and they all went through a Bowden. It just you have to have a Titan extruder That's the more key part. The part that pushes the filament through and in the tube, that thing has to be tight. If it's a little space in there, that flexible stuff will wrap all around it. You won't go anywhere.
Yeah.
Right. Yeah, you can't retract. Whatever you do, don't retract.
What I'm saying is it's a lot easier. You'll have a lot less failures if you have a direct drive.
Wouldn't y'all say that the less expensive you go with a printer, the more tweaking and finessing you need to do to get it to come out right?
Oh, yeah.
That's why I'm saying it depends on the printer. Like these, the ones I got for $150, they're not available anymore. Were a copy of a copy. I think it was the Wahoo. Remember a copy of the Wahoo, and it was basically a good design.
I thought it was a Persa i3 that it was the ultimate copy of, right?
Well, it probably was, you know. But I'm just saying, mine was several generations away. And I've used them now for years, and never had any really major
the Persa
problem.
i3 is basically the best design out there, and everybody effectively copies it. If you'll notice at the Micro Center, those are basically variations of copies of it. It's just that company seems to
when
have
they
pretty good.
with the creative whatever
Creality.
it is, Creality. With the Creality, they broke the mold and they started using extrusions, aluminum extrusions for parts, and that gives you a lot of nice features of rigidity and whatnot. And so, John, I mean, literally, because my daughter's done this, she bought one and she set it up. She knew nothing about 3D printing. She just she's into modeling, so she knows a lot about modeling. So she just sent it in there and it just started working.
Right.
I mean, it's
I don't
just,
think you'll have that much
it's not a
problem
big
with
trouble.
it. It's just a matter of, which one to buy. And personally, the Tree ones, so far I've been happy with it. Yeah, I'm up to 3+ printers, from the resin to I have the Dread drive, I have the Bowen the old one is a Bowen, that one's the Dread drive. So
I got to admit, I'm with John though. I also prefer the direct drives over the Bowden
I would tend
tubes,
to.
but
That's why I'm printing.
but in theory, the Bowden tubes, because they don't have the mass on the X direction, they don't have the mass that you're slinging around. They should be able to print faster. So that was the reason why they did it in the beginning, was to get rid of the stepper motor being mounted on the
X
carriage.
Yeah. Well, I'm talking about tweaking. An example of tweaking and finessing is my older printer that I tried was a Lowellspot Mini, much more affordable than the Prusa printer, but the technique that it used to level the print head each time is it had 4 washers in the corners of the bed, and it would make electrical. It would lower the nozzle and make electrical contact with the washer, and say, okay, now I know where that washer is. I know where that washer is, and so on. Problem is, if your nozzle was not absolutely clean, it would not level correctly. If you're printing with something like PETG, the PETG filament would build up on the parts of the head. PETG is like tar, and I was constantly having to clean my nozzle in order to get the printer to level correctly. Now, that's not a problem with this more expensive printer I got, because it uses that little infrared sensor and never actually has to touch anything. It just goes to various points on the bed to level.
Yeah, but like I said, I'm not afraid. I don't have any bed leveling sensors on mine. And I level them, and like I say, I don't have to worry about it for 6 months, and that's with pretty good amount of use. It really depends on where your bed is starting off. If your bed is flat to start off with, then you're in good shape. But if you've got, I have seen some of the inexpensive printers, like I say, who have warped or bowed, or even worse, they have dished. dished beds, and if you come across, in the middle, you got too much space, and in the end, if you adjust for the middle, then in the end, you're going to be too tight. And you also get used to watching it. I mean, with experience.
Carl's
can,
pointing out that we're probably going a little long on this, and we got more people.
Yeah, Ross. But if you're interested in just hit the list.
Well, you guys will get a ping from me for sure if I'm going to pull the trigger.
And it looks like you can count on some excellent feedback, Ross. So
well,
you got the fire hose.
You got enough people.
No shortage of opinions.
Yeah, you're not going to have any shortage of help. Being this tough. The problem is it's not all going to be the same help.
And you're going to have too much of it.
Well, I'm free to pick and choose. I'm free to pick and choose. So
all righty.
It's going to depend on basically how much money you want to spend and what resolution you want and how precision you want. In other words, I will push to tell you resonance nice, okay, but the catch is unless you want to spend money, the bed size is small. Okay.
Yeah.
Pat, you got a late breaking video, and then we'll get on with next Chris and Paul.
Yep, I've got a video to present again, and the latest, greatest I did while we were talking
about printers.
About printers
and printer that prints straight.
I bet Chris made a whole new robot in this time.
And the thing is, Murray's not even here to agitate about 3D printing.
Oh, he's not. Yes.
We'll send him a link. He'll break the internet with email.
For some reason, I can't share my video window, so I'll do my screen again.
Ross, the inside joke is that Murray hates 3D printing.
In what way? In the way that he needs it to work and it doesn't work for him? Or
he thinks it's a fad and it's overblown and metal is the way to go.
Right. He tends, because he doesn't have it, he thinks it's easy to build basically without. And
okay, guys.
The problem is, with a 3D printer it's nice to have. Once you have it, it's like,
looking pretty straight there.
Pat, that's really straight.
Like it's doing right.
What do you do differently, Pat?
Who suggested I measure the circumference with a string?
Me.
So my wife has this
real
measuring tape for sewing.
Holy moly!
Oh, yeah, cloth tape.
4 millimeter difference in the circumference on both wheels.
Whoa.
Wow, that's significant.
Compared to the video that got you the gold star, Pat, this is a really gold. This is a 18 karat gold star.
So I stop about 4 inches off from where I started.
Yeah, that was a lot of people's suspicion is that you have different diameters.
Yeah, well, hey, thank you everybody for that.
Inspired by this. Good deal.
Symmetry is great in nature,
Well, I think it's good enough for now that I'm going to move to the next step and get my sensors working again, and basically put a couple obstacles in the way and see how far we can go.
Cool. Nicely done. Way to go.
Thanks. Thank you,
All right.
guys.
All good. Chris, what you got?
All right. So let me share.
Got to let the Ross guys talk. They're chomping at the bit here.
I'll keep the Ross jargon to a minimum. This is not
I'll stand in for you, Chris.
I don't like to get caught up in jargon. So, all right. So, okay. I'm just gonna recap last week. So, I showed this video last week where I started at. Wait, I'm on my mouse and on the wrong screen. Okay, yeah. I started at this location here. That's my X and Y00. I manually drove it over here. And now it's trying to navigate back home, while avoiding my artificial obstacles here. And it didn't do too well. It was kind of doing this thing here, right? It's a kind of seeing the wall, oh, getting away from the wall, but not really making any progress. It's just real silly looking behavior. So it was sort of doing it, but barely, right? It was just, yeah. So manually driving it away, letting it go home, and again, it's kind of oscillating. And we talked about a couple different theories. I have some latency in one part. I have very wide field of view, and just maybe I'm too sensitive on detecting, the wall as an obstacle and so on. So there's a couple theories and a couple things I ended up experimenting with and tweaking and parameter tweaking and so on. What in the end, all right, and let's see, where's my mouse? Wrong place here. In the end, what I ended up with, I'll show how it's doing, and then I'll explain how I got there. Guys, I already drove it away from home, and again, it's trying to make it, it's trying to find its way back home, and as you can see, it's still doing a little bit of a dance, but it's not an apples to apples comparison because I set up my walls differently. I tried to make it harder and harder. It's doing reasonably well in the easy case, so I kept making it harder. The bottom line is it was doing much better, right? It was not doing as much of this dance, without really getting anywhere, and it was reasonable. Again, I tweaked a number of things, but the thing that made in the end the real difference was the realization that when the realization was, after staring at this for some time, that when it's when it was in kind of this situation here and oscillating back and forth between obstacle avoidance and navigating home, right? If you can see, where's home? Home is like, what, 90 degrees away, right? From where I'm currently headed, no more than 90 degrees. And so I have this logic in my waypoint navigation where if my heading is like way off, I basically try to turn in place. And so that's what was happening, right? In this situation is navigation says, oh, I'm way off with my heading. I better just make, a turn in place, right? No forward motion, just turn in place. Well, as soon as it's doing that, after a little bit of it doing that, obstacle avoidance kicks in and says, oh, wait a minute, there's an obstacle right in front. You got to turn back, right? Then we turn back, obstacle is gone, navigation comes back in. All right, I got to turn this way, right? And so it keeps doing that, and there just wasn't, nobody really was telling it to go forward. I mean, very little. There was a little bit of a forward motion command component that I still had in there in the navigation and even in the obstacle avoidance. But at the end of the day, there was just barely anything going on that was asking it to go forward. Everybody was just asking it to turn, right? So really the breakthrough was in the end, that realization. And what I had to do, right, it's to achieve this more reasonable behavior is I had to change my waypoint navigation to not do like a turn in place, but when I'm turning even, heavily towards my target, keep some forward motion also, right? And that way there is enough of a forward motion command that I don't get stuck in place and, jiggling back and forth. So again, it's still not pretty in how it's moving, but the logic basically is there. Now, one thing that I found that, and I don't know if you're able to see that, it may not be as obvious, but if you just go here and let it go to the end, you see here, I've reached my destination. See how it's not spot on, right? My 0, 0 location is where the two tapes intersect, but it's pretty close, right? And I'm not trying to go back to the original heading. I'm just trying to go to X, Y. But it's always been doing pretty well. Now, I don't know, for some reason suddenly, and I don't know if it's because of all this excessive jiggling, but the jiggling was there last time too. If you can see this, I'm like way off. I mean, what I consider way off. And I'm not quite sure what's going on here. I mean, I think it may have to do with the jiggling back and forth. That's, again, we're talking about odometry and limitations. I mean, I have the IMU. Either my IMU wasn't doing its job here, but I think I would be even more off. Or there's something going on where because of the jiggling and because I do have some slack in the gearbox, and if I change direction frequently, my theory is that slack in the gearbox, where I can turn the wheel a little bit without the encoders even registering it, right? I have a feeling there's an accumulation of that happening because I'm kind of turning back and forth. There's still a little jiggle going on. And yeah, that's just one theory, but I'm not happy with the accuracy of getting back home here. It's somehow it's started to do worse in my odometry than it was doing before. That's one thing that's not puzzling me. So that's where I'm at.
Chris, you I think last time you were talking about different ways to visualize what was going on. So did you come about this through a just like a behind the eyes, closed eyes imaginatory stupor, or did you actually have nice visuals and feedback to figure out what was going on?
He slept on it.
I did play with the visuals a little bit, right? And I did, but I'm not sure that's what really helped me in the end. I think it was more just a realization that, wait a minute, am I really asking it to go forward right now? Maybe I'm not, right? But yeah, so I think it was more that I wasn't able to extract as much value from my visualization techniques as I was hoping to. But
were you able to, because I think you're talking about maybe plotting the behavior that had control of the steering?
Yeah, I never got around and
didn't do that
and adding that functionality. I went straight to what I did do first was I added the ability to configure more parameters. There was still a couple of hard-coded thresholds and parameters in place. So I turned those into dynamically configurable parameters so I can tweak them on the fly. And so that exposed a few more parameters to me to tweak. And, that allowed me to play with a few things more efficiently. But I don't remember exactly how I realized that there wasn't this forward component. But I think that was one of those things that I turned into parameters. And then I thought about it, this is almost zero by default. Should that be really almost zero? Because if it's zero, I'm not asking it to move ahead, right? So I think that's how I realized it, not by doing the graphs. Yeah, and Ray is showing the slack in the gearbox, and when you would jiggle the wheel like that, the encoders won't even register. So
yep.
I don't know if that plays a role here in my odometry limitations here, but again, it was doing better previously, and then it's doing now, and I gotta look at that a little bit.
We could call this PAT syndrome, where your wheels are wobbly, or they might be different diameters. So
yeah, I mean, yeah, the roaming platform, it's and I don't know if you can see my camera image right now, but it's even in this direction, right? I mean, it's everything is kind of jiggling in kind of all directions a little bit, right? So even I don't know what the exact wheelbase is, but that doesn't matter because I'm using the IMU, but my wheelbase doesn't come into the picture for heading. I get my heading from my IMU.
Yeah.
But so I gotta look at the odometry, but I'm not gonna get hung up on it because that's a rabbit hole. You could spend your entire life optimizing your odometry and getting back exactly to 0, 0. At some point.
Chris, I was going to say that I bet you that if David was on, you know what he'd say? That's close enough. I bet he would say that's close enough.
Yeah, it's not as good as what David gets, but again, my mechanical platform is not good as his either. So yeah, there you go. Ray's showing again the jiggling.
They're pretty sloppy.
Yeah, it's the only platform. It's got cheap motors on it, and so it's a little sloppy. So there are limitations, and I'm not gonna.
Well, maybe that's a nice way to compensate for the fact that your floor is almost perfect. You know,
Yeah.
want to have floppy wheels. That way, it's sort of the
Yeah,
same.
I gotta have some excuse, right? I gotta have some excuse. Come on.
There's a little bit of grain in that oak flooring, though. I don't know.
Gotta have some excuse. So what, my next step really, so I wanted, this was kind of, again, I was on this path of really trying to make real good use of the LiDAR and a little bit of SLAM and so on, where again, things get more complicated and I don't always have enough time to keep all that straight in my head. But so I took this little, almost a detour. I wanted to, have something actually working that's useful and, gives me a sense of progress. So I feel I've achieved that. But so I think now I'm going to go back in my other branch, so to speak, of now doing more with the LiDAR, right? I was turning the LiDAR data into these virtual, range sensors, each one. And I was playing with those a little bit. And I have now the ability to change the field of view of my, virtual range sensors. Again, that's helpful. But I'm really not making good use of all that LiDAR data that I'm getting, right? So now what my current thinking is, again, the RAWS delivers a lot of building blocks for the whole SLAM and navigation stack, which I've always struggled with those black boxes, and it's just never really been working that well for me. So what I think I am going to do potentially is a little bit of reinventing the wheel or doing something myself from scratch that maybe I don't have to technically, but I'm a strong believer that it's going to be very useful to have an occupancy grid. I've mentioned that before, building an occupancy grid from the LiDAR data, right? It tells me where stuff is, right? And you update that as you get more data coming in. And then you can use that in a variety of ways. Again, there's building blocks in ROS that'll do that for you, but I'm finding them to be too much of a black box and too many parameters to tweak that I don't understand. So I started already a little bit doing a little bit of, in a very naive fashion, building up an occupancy grid from the LiDAR data, just so I get a sense for, is that something I can do from scratch? And, so I'll have to poke at that. And then at some point, I'll probably bring back the localization, which was working pretty well for me in RAW, sort of just the localization part where I give it a map, I give it the LiDAR data, it tells me where it thinks it is, right, to correct for any odometry issues. That's why I'm not going to get hung up on odometry, because my long-term plan is to use localization combination, with a given map, and part of it might get updated on the fly, but have a localization module tell me where it thinks I am, right? Not just rely on my odometry. And so that'll eliminate any kind of long-term drift of odometry or IMU. That's just going to go away, at least in an indoor environment in my use case, right? This is my use case. So that's where I'm going to get pretty perfect, localization at some point. But to get there, again, I need a map. I don't like what RAWS has in place, and I don't always fully understand it, and so on and so on. So I might build up an occupancy grid from scratch, and that's, if I keep it simple, that's probably quite doable. And then I'll have to see what I can do with that, because then, what an occupancy grid really means is, right, it's not just an instantaneous snapshot of the LiDAR scan, right? It looks like that almost, right? If you do a scan of the LiDAR, you're going to get what looks like a map, but it's just for that location that you're currently at, right? You move your robot, you scan the LiDAR, you're going to get a new map. I'm calling it a map, but it's just a LiDAR scan, right? What an occupancy grid really is, right? You really now have to take each observation that the LiDAR gives you and put it into a map that really operates on global coordinates. Right? You have to really now know, okay, my LiDAR is telling me at my second reading, which corresponds to degree 2, right, of the LiDAR, is giving me something that's 2 feet out, right? Well, where is that in real world coordinates, right? X, Y. What's the X, Y of that obstacle that I'm sensing with my LiDAR? So you have to do some of that math, and I'm not planning on doing that from scratch. So ROS is giving me a function that's convenient to use. So I don't have to do that from scratch, luckily. So it's very convenient to sort of turn the LiDAR scan into, individual, into a point cloud that's already in kind of world coordinates, right? And then you just keep on accumulating your readings. That's the idea, right? You get a new reading in the same exact spot. Oh, I'm now more confident that something is actually there, right? Or if you get your laser beam is, you have to do sort of ray tracing essentially. Your laser beam is now seeing something out in the distance. Well, that kind of means there's nothing in its way, right? So you kind of have to ray trace the laser beam and then clear the occupancy grid of any sort of thing, right? Or at least decrease the, probability of something being there. So I mean, that's a whole research field on its own. I'm sure. I'm going to try to keep it simple, and it won't be as good as some of the ready-made occupancy grid mapping solutions. But somehow again, like I said, I'm good with working with black boxes, but to a point, right? Sometimes you're dealing with a black box, and if you just don't understand it enough, then I reach a point where, you know what, I'm going to do my own box. So that's kind of where I am with some of the RAWS navigation stuff. I've reached a point where I feel like, maybe I'll do some of this myself, have more control over it, and learn something in the process, and and so on. So that's kind of my next step here.
Well, Chris, did you mess around with you were talking about changing your cones? I think you said you were using 30 degree 30 degrees of your. Did you change it like to 20? And
I made them 15.
Okay, you have them. And did you double the number of them now?
No, because that was going to be more work. So I kept the number. So each virtual sensor is still facing at 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, just like before. But now each one is only looking 15 degrees. So
gotcha.
Yeah, I think ideally I would double the number of cones, and so, but that was just slightly more work that I didn't want to do.
Gotcha. I still think that has a lot of merit for people. I think it would be a really interesting approach to take, as opposed to trying to handle the whole sweep.
Yeah, exactly. No, I think that was it, because conceptually it's so much easier to just think of, okay, I got a dozen range sensors, or maybe more if you make more cones, right? And yeah, they are conceptually much easier to deal with, are much more conventional, right? We are used to with the sharp IR and the ultrasonics. It's no different than that. And so yeah, I think that's what allowed me to make progress faster, right? Because it's just a little easier to deal with that than sort of something more sophisticated.
It looks like a gold star for driving your robot along the wall.
But ultimately, right, the reason I'm going back to now pursuing again something that's a bit more SLAM or has elements of it is because there's limits to how much you can do with this. And I feel like with purely with subsumption, right, there's a lot of art in it, in how to just tweak the interaction of the behaviors and just right so that you get the result you're looking for, right? So I feel like I got to be able to do a little better and control the motion of the robot better and do less based on reflexes and a bit more, deliberate planning. So I think I want a more balanced approach here between reactive and deliberative sort of decision making here, because I feel like you could even with the motion planning, you could take a simple approach where you use waypoint navigation, but you just piece together waypoints that are not very far apart. If there's this obstacle stuff here based on your occupancy grid, the LiDAR, let me take my long-term goal is go back home, right? But to get there, the LiDAR scan tells me right away, don't bother going this way. There's stuff there. Why do you keep turning this way, right? Just don't do that. It's stupid, right? So
I think
I see an opening here. Just set a waypoint here. Just go there into that opening. All right, now we reached that opening. Okay, yeah, we need to get back there. Well, okay, let's go here. Next waypoint, next waypoint, next waypoint, next waypoint. All right, and we're home, right? So something along those lines. You're starting to make use more of the LiDAR data, and it's, you know, you're not just relying on the reflexes and the behaviors just magically, you know, emerging the behavior you want, which is very fascinating, and I'm sure can be very resilient to what's going on in the environment, but it's going to require a lot of tweaking, and it's still going to have its limitations, right? So
Yeah.
that's.
So, Chris, does your
It'd be
higher level
be
code then
real
have-
interested.
Sorry. Carl,
I'm
go ahead.
sorry.
I was going to say, does your higher level code then have methods called "Don't do that, it's stupid. Do this instead"?
It will have. Yes, it will have.
That's what I call self-documenting code. But okay.
What's that line? Don't be stupid, you moron.
I love it. Hey, Doug, what were you saying when I stomped on you?
Well, I kind of like the idea of having a line that says, do something stupid here.
Well, that would cover quite a lot of my code, so I couldn't use that one.
Yeah. You know, I mean, it's like, all right, I'm out of ideas. You know, my non-stupid code doesn't know what to do. Now just let the reflexes take over, right? Maybe they'll get us there. Yeah, it's kind of a fallback, you know, because it'll try whatever, right? It'll walk around, it'll jiggle its way out of potentially more of a jam, right? Than any more deliberate planning. So there's a place for those reactive behaviors, right? There is a degree of robustness there. You can let that kick in when you just don't know what to do.
Shake it and see what falls out method.
Yeah.
That's awesome.
It works. You can't argue with results.
No.
Yeah, it
Gold
works. The
star.
subsumption
Gold
works.
star.
I mean, you know, maybe at some point I'll come back to it, right? Because where it gets more interesting, right, is when you have additional behaviors, right? I have exactly 3 behaviors. Manual control joystick, well, it doesn't even count really. And then I have waypoint navigation, and I have the obstacle avoidance, right? It doesn't really have a purpose right now. And that's the other thing where I find the limitation in this, right? Is if you have a robot that has to complete a very specific task, how do you do that in the subsumption kind of architecture? I don't know, to be honest, right? Again, maybe you're turning pieces of it on and off as needed, right? And I mean, kind of that's what I was doing in the past in a way, without explicitly doing it subsumption style, but you turn kind of reflexes on and off depending on where you are and you're making progress towards your task that your robot's trying to complete. But you know, I want eventually something where I can say, yeah, this robot's completing some semi-useful task, even if it's just an artificial one, right?
Yeah, I think in what I've seen of David's stuff, what he has is he actually has, like, he has different tasks that would get added into the program. If he was, let's say he was doing can where he's going to try to drive to a can, pick it up and drive it off. He'd have a find the can, go to the can, take the can home type task, you know. If I don't want to speak in his word, but I want to say that's
no,
how
you're
he-
right.
yeah.
I think I've seen that or have him heard talk about it or something. Yeah, I mean, you're
Yeah,
right.
yeah.
I think that's what he's doing.
Okay.
Yeah, that's all.
Very
Any
cool.
other questions?
So next week, obstacle map or avoidance map, whatever you call it.
Well, I have the beginnings of that implemented. I can show that what that looks like, but it's pretty primitive, and you know, I don't know how far I get next week, but yeah, sort of maintaining, you know, accumulating the sensor data, the LiDAR data into a map is. I have a very primitive version of that, but it's, you know, it's not doing a very good job right now, and I have to figure out how to keep. You know, there's a balance between the resolution of that map and how much overhead there is in shipping that map around over the network, right, to everybody who may want it. Because think about, let's say I want to cover a 10 meter by 10 meter space, right? That's my my use case. There's this room and then out the door, down the hall. Okay, 10 meters by 10 meters. I don't need more than that for experimentation, at least, right? So at 1 centimeter resolution, okay, so we're looking at what? That's what, 1,000 centimeters by 1,000 centimeters, right? Now you're talking a million pixels, and now you gotta move. I gotta move that over.
I'm not sure, Chris. I wouldn't do it that way. That's definitely a way that will work, right? If you got enough memory and you want to shift it around. I would look for something called, the concept has been around for a long time. It's called a sparse matrix. So the idea is you keep track of interesting things, but most of that is probably going to be empty space that you don't care about. So why are you tracking empty space? That's the idea.
I don't need to find out how to tell ROS to do it that way, right? Because it's got a way of representing a map, and it's a bitmap, right? It's a non-compressed map. So I have to see if there's a way to make incremental updates to that bitmap, right? So where my logic that's maintaining that map, memory is not an issue, right? I mean, we got oodles of memory on the Raspberry Pi, but sending it around, it takes actually a good amount of resources. But,
it does.
But at any given point in time, I'm not updating my 10 meter by 10 meter map, right? I'm just updating something much smaller. I just haven't come across a way to sort of send a message out to everybody and say, hey, here's an incremental update to the map that I sent you 5 minutes ago.
One thing
Maybe
I was
there's a way
thinking
to do
about
that.
your pixels. Why would you want the pixels to be centimeters when the robot is much bigger than that? You really want to know if
that's
the
the
robot
other
can
thing. I can play with the resolution. You're totally right. Centimeter gets like a little less than half an inch, right? Make it an inch. Maybe
Make
that's
it a
good
foot.
enough. Well,
make it.
Now, you know what? I do want my robot to be able to go, where's my mouse cursor? You can see it. I do want my robot to be able to pass through openings that are just slightly bigger than my robot, right? So if you really reduce the resolution, you can't really tell how wide that opening is anymore. You can't tell the difference between this much of an opening and this much of an opening. That's of no use, right?
Well, but
I have a relatively small robot.
I think that depends on how you're using your map, though, right? Because if you have this map of a big, large area with your 10 meters by 10 meters space, and if you have it relatively coarse grained, so it's not huge, maybe that gets you like in the right ballpark of where you are going to fit for sure and where you won't fit for sure, and then you can use the behavioral emergence stuff to get fine tuning, right?
Yeah, maybe, but 1 foot by 1 foot, my gut tells me that's just way too low of a resolution.
Sure.
I don't know what the right number is, but you're right. It doesn't have to be a centimeter. That's true.
Or building off of Carl's idea, you could have a second map. Otherwise, you have a map that's say 1 foot around the robot, or 2 feet around the robot. All right. So all it is it's going to be, you got the data, so it's only just remanipulating the data. So like Carl says, if you're trying to decide whether to go down the hallway, you don't need it. But if you get close to a point that's a choke point, then you might need to just say, okay,
Keep it simple,
I'm not sure here. Yeah.
Don't have too many things. Keep it, if you can handle 1,000 by 1,000 array, go with that.
Oh yeah, memory it's not an issue, but it's sending it over the network. I found that to really bog things down.
Okay.
Well, there is a problem. So I would say half. Half the
When it
size.
all comes down, when it
I
all
mean,
really
cut
comes
down to half.
down, it really comes down to, do I go this way or I don't go this way? That's a decision you have to make. So maybe you don't have to transport all of that information around.
Yeah, and I have to look at, again, within ROS, I know there are different representations for a grid map and the multi-resolution map. All kinds of sophisticated things are there, right? This is not new. The primitive single resolution grid map is kind of obviously conceptually the easiest thing to deal with, right? So, I'm probably going to stick with that. I know that there's other ways there to do it, but but it's going to be harder to generate, and not every ROS feature understands it, I think. But every ROS feature or visualization feature understands the primitive grid map. So I just have to poke at this a little more, see what my options are. And
I think
maybe
Doug made an important point about not shipping it around, and that was what they did on the trucks that I worked on. They had the map and the planner running on the same exact CPU, so it could run in memory. That's a real important point.
Yeah, it's the only reason I'm shipping it around really in the end is for well, visualization on my laptop, right? So I have to ship it over Wi-Fi, to my laptop.
Yeah, that's a sort of a different aspect of the problem, and you have that in spades with RViz, where when you start getting a decent amount of data going over to RViz, it sort of like falls apart, and that's sort of different than the resolution of the obstacle map issue.
Yeah. So anyway, I need to, poke at this some more and play with this, but that's those are my next steps.
Nice.
Well done,
All
Chris. Gold star. All right.
Thank you. Thank you.
So next we have in line, I think, Paul, and then no one after Paul. So think about if you want to jump in then. But
I have something I can show.
Okay.
I wanna
So we
jump
have
in.
John K, then Doug P. So Paul, then John
All
K,
right.
and Doug P.
So hopefully just find the right window to share. Where are you? Where are you? Where are you? Where are you? There we go. Okay, so this demo is not very grand, I'm afraid, but I've made, but it's I guess a demonstration of some success in a major re-architecting of the Mobot hardware and software. So we got the little Xbox joystick, and now there's a major problem here in that
That's pretty noisy.
ran into the wall. so that's the end of the demo. The major problem is that I've got queuing somewhere in the system, and I don't know where, but I want to show another aspect of what I've been doing here, which is along the lines of what Chris showed a couple weeks ago, is tooling. So hopefully you've seen this, and so this is the Swiri console, and it's showing the logs that are coming out of a combination of ROS software running on the Raspberry Pi and logs coming out of the Arduino ESP32. So this was a very valuable tool to help debug the software. And where you see like an I or an E in front, that's information or error log that's coming out of the ESP32 Arduino, and it's got a timestamp at the end of the line showing the Arduino time clock, or actually it's the FreeRTOS tick count when the log was issued, and it's a log4j style of logging system, much like Ross's, where you call it with an error level, which could be debug or info or warn or verbose or error or fatal. So the ones with an I are coming out of the ESP32. The ones without an I or an E or some other preceding letter are coming out of the Python node running on the Raspberry Pi, and being sent over the obviously over the network, and Swery console running on my laptop, subscribed to the logs. So the magic that does this is in not this one. Let's see just which one I've got. Here we go. Where is it? There was that's the wrong, sorry, that's the wrong web browser window. Why? That's not. Well, hang on, let me just find that other web browser window and get the right window dragged over onto it. Here we go. There we go. So I found this package, and Pat sort of turned me on to serial transfer as a package for communicating between the ESP32 and the Raspberry Pi. And then there's this other package, Arduino Log, that is very easy to use, and it's just a library that you build in and you call it, and it supports different log levels, like I said, and it's got instructions how to install it, and you just call it to something like log.begin, and then you give it the verbosity level and a pointer to a serial port, and then you can log error line with some message and print out the messages, just pretty much like a sprintf. So that was a real helpful from a debugging standpoint. And then just a reminder of the hardware architecture of this. I've got the Raspberry Pi with a serial link, and I've implemented this as a dedicated serial link down to the ESP32 running Arduino, which has the encoders and the serial to the mower and the serial for reprogramming it. And I had an interesting discovery when I was putting this together. I spent several days in dependency hell because I didn't used to have this is the software block diagram, or the class diagram actually, of what's running on the ESP32. I didn't used to have Mobot Mediator. And so there are three major classes in this system, each of them running their own thread of execution. There's the odometry class that takes the interrupts from the odometers and computes the odometry and sends it up to the Pi link, which is a serial link up to the Raspberry Pi that uses Pat's serial transfer library. And then there's the RL500 comms task that sends messages off to the mower and gets them back, things like get the battery and set the drive motors. So three major classes, each of them with some smaller classes around them to do things like handle messages. Well, what I found when I was putting this together is odometry needed to call PyLink, so it had to include its .h file so that it could call PyLink and call methods to send odometry. PyLink had to include the .h file from the received drive motor object, which had to include the help file from RL500 comms task, so it could call the method to publish motor speeds. The comms task had to call mobile odometry, tell it when the direction changed, and it had to call PyLink. So here we have a circular dependency chain of include files, and that I just could not get that to build. It was the compiler couldn't figure out how to solve that circular dependency. And so the solution, looked on the web and found a solution which was called a mediator pattern. And the mediator pattern is a object-oriented design pattern in which there are multiple peers and something that mediates communication between them. So the peers don't need to know about each other or about the guts of the mediator. They only need enough knowledge to be able to make calls of whatever their particular method is into the mediator, and then it passes off to the next to whichever object that thing is supposed to talk to. So it's a scheme for reducing coupling between objects. And there's a good Wikipedia article on it, but I pretty much used this diagram as the guide to implementing this. And so the mediator has like 4 methods in it, which are called by the objects that need to get something to happen in another object. And then that mediator is subclassed by a concrete mediator that actually does all the work and knows about includes all the .h files from the other classes like RL500 task, comtask, and odometry and PyLink. And so these things just contain a link to the mediator, and they call the mediator saying, set the direction or send odometry. And the concrete mediator, which it subclasses this abstract class, goes off and does that and communicates with the appropriate other object. So anyway, that was like a major sort of it got me out of several days of trying to make this huge collection of objects even build, much less talk to each other. So that was a real interesting learning experience to discover that. So I think that was as much as I had. So 3 points there. The robot running with the ESP32 running this whole collection of software. There's still a few objects need to go in there, like a PID loop and collision bumper sensors and so forth. But this is the guts of it. A link to the Pi, an odometry, and something that controls the robot, and a mediator to hook it all together. And then the tooling. And so the console logs that I was showing before are handled by this TX log thing. So each object has a logger in it, which is that Arduino log package that I pointed to. So odometry has an instance of it, RL500 has an instance of it, and PyLink has an instance of it. And they all, and the logger has a log stream that sends a message into the mediator, and that pumps it on out either to a serial port or up to the PyLink. And that's how these log messages get out of each of these 3 major objects and their smaller door or colleague objects up through the Pi link up to the Pi, where a Python script not shown in this drawing publishes them to the ROS logging infrastructure. So anyway, that's all I had.
Some pretty good progress there. And also a gold star. Very nice. So could you?
I like the chicken scratch diagrams. I have a notebook full of them. You know, those are, you got to have those. So
Yeah.
make sense of anything.
Right. They help you figure stuff out, and they keep a record of what you did. And I'm also putting together a web page with some of the stuff, but it's sometimes out of date, and it's like, yeah, it's a thinking tool.
Mm-hmm.
You showed that one diagram, Paul. Do you have some links for that mediator pattern and any reference, something that might help?
Yeah. Let me post a link in the chat to the Wikipedia article on the mediator pattern, because it really saved my bacon.
Thank you.
And yeah, it decouples what otherwise are relatively strongly coupled objects. Well,
I just know I keep stumbling on these cool looking patterns, and then I try and implement them, and I'm just, I don't know, lost.
Well,
Carl, don't feel bad about being lost with some of these patterns, because that mediator pattern, they're the same guy that does AutoFac and a few others. They've been touting it around the higher end object oriented stuff for the last few years, and I got on a team about a year and a half, 2 years ago that that was using that, and it confused the hell out of me. And it was already set up, and things were working, and things were outlined, and all that kind of stuff. It took me a little bit to get a hold of it, and I never truly have. However, once I play with that and going forward, it's actually kind of cool. I mean, the idea is you're part of this object is a mediator type object. It looks through there using reflection to do a few things, and it has guaranteed methods, like there has a handle method or a setup method, that kind of stuff. So all these other things know that if I need to go do this, I'm going to send it out there. The other thing is going to say, ooh, you say you know how to deal with this type of thing, and so I'm going to call you and invoke your handle method and pass you the stuff, and then I'm out of there. You know, you just kind of fire and pray. And it's not really a fire and pray, because we're good people and doggone it, people like us and all that kind of stuff. But it's designed that way. But it's to solve the circular dependency that Paul was directly getting affected by, and that happens all the time in large projects, especially large distributed projects, because they have all this stuff that needs to know about all these other things. And as soon as you start doing DLLs and putting all this into that into that, and this other thing down the road needs this thing at the beginning, and now you got your circular stuff and you're kind of screwed. So that's all in the name of decoupling. It's if you go look up mediator pattern, you'll find tons of stuff on YouTube and all that kind of stuff on it. It's a pretty popular idea. There's some religion going on there, where some people say doing that takes too much time, too much memory, whatever. But in the space most coders normally work in, you know, space and time, you know, memory bandwidth is not that big a concern most of the time. Certainly not like we're concerned with memory and bandwidth and stuff dealing with our lower powered machine.
I figure if it lets you keep your hair, it's worth something.
Yeah. Well, it'll pull something out when you're learning it, but then eventually you will keep what's left of your hair. Yeah.
A lot lot of times it just depends on what you value most. Do you value being able to maintain and debug your code as much as you should? You know, that's one of my factors.
I agree with that. I agree with that.
I'm all for code that's debuggable and maintainable. You know, and I'll sacrifice memory to do it.
Yeah. And it's really only one extra, well, maybe, one extra call, because the one object calls the mediator, and then the mediator calls the other object that the message is supposed to go to. So it's not like storing extra stuff. It's not really consuming much memory. It's and one call is just in the noise as far as time, but it's more about the simplification of this and decoupling of the software, like Harold said.
Yeah, I think, the last company I worked before I retired was Siemens PLM, and I think they suffered from that problem you're talking about, where, performance is everything. Everything else is of secondary consideration, and they don't realize just how bad some of the sacrifices can be.
Yeah. Another interesting data point, just while I think of it, about this, and I got to say, I'm a super fan of the ESP32 running Arduino. So that whole bunch of software that I just showed is currently using 17% of flash, so it's using 230 kbytes, and 5% of RAM at 15 kbytes. So if you're using an Arduino Uno, you are so like, and this was $20. You are like so down in the at a lower level of capability than you've got in this kind of little teensy little board. It's just it just amazes me how far how powerful these chips have become in the last 10 years since I played with them.
Yep. And cheap.
Yeah, they are.
Pretty cool. All right. All gold star. Excellent. So then, all right. So that's John K. and then Doug P. I think we have.
Yes. So I have something that can, I think, add for Halloween next year, or this year. So add to the spider robot thing that you had that drops down. So you might find this of interest. So let me click on the window. See if I can find the window. Oh, where do I have you? Come on. Where are you? I think this is it. So I found this. Okay, here's the bolts and parts that goes in it, and this is how it looks. By the way, it's 3D printed, but I'll play it, and I think it'll be cute.
Is this the chatterbox thing?
Yeah, it's a chatterbot with eyes moves, and it looks so perfect to add.
Ooh.
So yeah. So you might find that interesting in print.
How many servos does that use?
I think one or two. Like here's the
Yeah,
parts.
it doesn't look like the eyes go up or down. They just left
Right,
right.
it goes
So
back
it
and
probably
forth.
only needs 2 servos.
Yeah,
one for
two.
the mouth and one for the eyes.
Yep, it shows here too on the list of parts. So yeah, I saw that. I thought, yeah,
Okay.
you couldn't go wrong with it.
And you
A
could
little
use the
humor.
teeth to perforate something if you wanted. You could.
So yeah, I thought that was of interest.
What's the stick out the back?
Out the back, oh, the candle on top, same as a cupcake with the candle.
Oh, that's what it's supposed to be.
Oh, okay.
Yeah, with teeth on
I
the
thought
bottom.
that is a cupcake. That's the cupcake from hell or something.
Or something.
Or something. Well, seemingly this guy, let's see what he said. Character from some animation that this daughter Yeah, so I'm thinking, I don't know, but I thought it was semi cute, and yeah, to add it to the Spire drop down. So, so yeah, so there's that.
He didn't say whether his daughter was suffering from nightmares or not.
No, I would. I think if I saw that, but and then the other thing, I'm show it briefly since I think somebody has one of these robots. So let me see. Okay, so I don't know if somebody has this robot, but I noticed that you can print a little holder that goes on top to hold the phone for it. So speaking of, yeah, the little chips robot thing, this one's not as scary in some ways, but it's useful to hold the phone, which we know can. So yeah, whoever has this real robot, one said somebody had it in the group at one time or another.
It looks like it may use a microbit. That may have been Murray or.
I want to say Murray, but yeah, it's been a while. But with we had that one that, yeah, oh no, I know. Carl had that one. Didn't you have Carl one of those robots?
Well, I didn't make one on that base. I mean, I found other ways to slap the phone on with the tripod and duct tape, but
okay, but didn't you have the base, that robot base? So I'm thinking,
no,
or something like that. Okay,
I never one like
what's,
that.
What's the purpose of the phone?
Well, it has your GPS and other goodies in it, and
Oh, so
accelerators and that.
They're borrowing some functions from the phone. Okay.
Right.
Yeah. I was a big advocate on that, and I think Kareem and Iron Rain too, because I mean, there's so much power on a typical phone that if you just make the connection, then you get a whole bunch of sensors for the price of one device.
I thought that was a nice sort of way that they mount the phone on top of it.
Yeah.
So I thought that was sort of nice.
Doesn't look real secure.
Well,
maybe not. Don't use your best phone with that setup.
No, use your $35 phone.
There you go. Yeah.
The one, the 3G one that's going out of fashion the next month or two or three or however many.
Today it was actually.
Oh yeah, that was today. Yeah.
For AT&T at least.
Yeah, I was going to. Well, they kept bumping it back, depending upon how close you were to an airport or something. Seemingly.
No, that's 5G. This is retiring 3G.
Right, because.
So my 700 or 800 deployed devices for my company, that's consumed a lot of my last week.
So it did affect you, okay? Because seemingly it affects a lot of things.
So
that
you were
people
using 3G, Carl. You were using.
We use devices with SIP VoIP to analog telephone adapters, and they use LTE modules. They're LTE branded devices, and wouldn't you know that they're also 3G capable? And after a year of feeling really confident, a month before the AT&T shutdown, vendor says, "Oh yeah, by the way, it wasn't coded right, so it'll still try and attach the network via 3G, then transfer to LTE. So if you don't change your firmware, then you reboot your device and it won't attach ever again. You've bricked it effectively. So, and we have like 700 or 800 of these deployed in customers' premises around the country. So it was a bad week, but aside from that, the firmware. And here's the best part, right? So the vendor, AT&T, say, "Oh yeah, we're going to shut this down." Do they provide a test bench so you can verify the changes? No. So did I just push like code to 700 devices that's been unproven against a tester? Am I like crossing my fingers that the company is still around tomorrow? Yeah.
Yikes. Yeah, I thought they were supposed to get rid of 2G in 2020, but I still have a 2G module that works. Like I send SMS.
Well, that's another,
but it's still working.
Then apparently the little birdies get in the ear and they say, "Yeah, well, this is the official line," but then unofficially they're not going to kill themselves, so they've actually they put something secret in the network, so it just might keep working a little bit. For crying out loud.
Well, a lot of times these protocols that they come out with, they're almost always backwards compatible to some degree. All they're doing is layering additional features on top of the old ones so that they can migrate easily. It's just that you won't get not all the features may work anymore.
Yeah. Well, the one I cared about was like registering to the network so that it could pass a data connection later on. No key to the front door, no get in, no good. Anyhow, I'm sorry. I didn't mean to give an update like that, but cool, John. Well, thank you for those Thingiverse things. We can't wait to see what you print next.
Well, I thought that was especially perfect for John, his spider.
Yeah.
And then the other one was mainly how they fasten the phone to the top to give it more power.
So I think we had Doug next. Doug P. Unmuted. There we go.
Yep. I haven't really talked anything about robots in a while, so I thought I'd like to just share a little bit of what I'm hoping if the weather will work with me, and I can get the stupid Pi Camera C library installed, which I'm struggling with. If I can get that done, then I'm going to take this little guy right here, and he's basically got, Pi Camera, Pi receiver. So he's not going to be a robot. He's really just he's just really an RC car, okay? That's going to be taking pictures. So the intent is to drive him around in the backyard and gather my cone and non-cone pictures so that I can start on my Haas Cascade cone program. So that's the first step. And I just thought I'd say, well, I'm still doing some robot stuff, not much, but a little bit. And that's it. So that's all I had to say. Oh, and welcome, Will. Welcome, Will. Hadn't seen you in a long time. I just noticed Will's on.
A small update.
All right, John, what you got?
Working on my Halloween project. You saw that I had added have a jaw and the lower half of a face of a skull there. I've been modifying those. The model I've downloaded is all STL files, so it's kind of pasting things together in Prusa Slicer. So now I've added the top part of the skull there, and I'm trying to figure out how to mount the camera. Problem is that ribbon cable on the camera comes in from the bottom, and I can't find a good way to fit it in there. So I think I'm going to actually put it on the outside, allow the ribbon cable to come over the top.
Can you put it in upside down?
Yeah, I'm gonna put it in upside down and then invert the image.
Yeah.
Yeah, rotate it.
That's all.
You go sideways or upside down, doesn't matter.
So is that the chakra point where the camera was mounted there? The third eye?
Now, basically, I just printed out I'm just going to mount the camera inside this little box here and have it on
the Cyclops.
Yeah.
John, it's looking like you're ready to get into the oral malefactial and facial reconstruction business there.
Well, this guy who put together this skull model that I downloaded, I don't know how he put it together, but man, it's something else. Pretty realistic and pretty educational, as a matter of fact, because he basically modeled all the bones of the skull separately. I printed out his.
Yeah, look at that. I mean,
and they're all attached. All the separate bones are attached together with magnets. There's over 100 magnets holding this thing together.
Wow.
I wonder if he started out by scanning real bones.
He probably did. I mean,
Yeah.
I can't imagine having having done this in any modeling program just by hand.
Oh yeah.
That would take some real artistic value. He probably did some scans and then added the points in here for attaching the magnets.
I'd hate to be his neighbor.
What?
That may be his neighbor's skull.
Yike. Yeah.
I'm thinking when John gets to his Pi connection, he's going to start the tree panning.
John, are you going to put eyes in that? I was stepped away for a minute. Are you going to put 2 cameras for the eyes in there or what?
Well, no, the camera is I'm working on the technique now. Well, but it's not. This is not in the skull here. I kind of have this thing somewhat dismantled over here. Let me pull the camera up here real quick and see. Got it sitting on the table there, taken apart. The eyes are. You haven't seen this before, Glenn.
No.
This design I borrowed off the web or from Thingiverse has eyes controlled by 6 servos here, where you can go left, right, up, down, and then you can blink the eyelids. So what I'm trying to do is I'm trying to integrate that project with the separate skull project that I found on Thingiverse.
Can you put the link for the eye thing you got in the chat?
Yeah. I got it. I should have it right here.
But what's the cameras look like? Are you putting a dual camera Raspberry Pi
No, it's just
camera?
a single Raspberry Pi camera mounted at the top of the skull face that will track faces and allow me to move the eyes to track the faces.
Oh, okay. You don't care about making cameras for the eyes. It's just a central camera.
No, yeah. Yeah, that would be a real job trying to get that to work. Let's see here. I've got this under robotics. Here we go.
Yeah, if you've ever taken a course in human anatomy and physiology, word was that they, offered, I guess, very poor, Indian people. Basically, after they died, they would have access to their bones, and those were the bones that you were examining in those classes. Don't know if that's true or not, but.
Well, when I went to Nevada, I went to the Body Museum. I think that's what it's called. And yeah, they had like some Chinese people. They had like I don't know. There was big controversy over how they got the bodies, but the bodies were all Chinese people, and I'm like, okay, this doesn't look right, legal.
It's 11 o'clock.
But they weren't representative of real American people. They were all very skinny people, very skinny persons.
More recently, those Bodyworks exhibits where the guy plasticizes willing participants. Those are pretty remarkable. If you ever get the chance and aren't too grossed out by it.
So what does he do? Make plastic 3D models of?
Oh no! They have people sign their bodies over for this for whatever reason.
Oh yeah.
Everybody from athletes to non-athletes to people with diseases to and then animals too. But he has a way of I guess I remember it's sort of like embalming, but not exactly, and it's a way of replacing the more liquidy tissue, I guess, with polymer of some kind. So they can accent the venous structures or the skeletons or the whole different kinds of tissues, and they do different kind of cross-sectional slices. And it's almost like a CAT scan, but it was a real body at one point. It's some of them, and then some of them are 3D printed.
Yeah, I saw that and I read that, and it ooped me out enough that I can look at that as I drive by the show in Vegas. I have no want to go into that place.
If you can stomach it, I mean, I have to encourage it for just appreciating how delicate and
I went in there. I wasn't grossed out because it wasn't like it was body fluids, right? It wasn't like it was flesh and blood.
Yeah.
It was just bone. So it's like more mechanical thing, you know. It was just like, okay, just bone structure. So it didn't really gross me out at all.
That's good.
Yeah, apparently leather, they don't use, they used to like submerge hides in water, and there was some chemical change that went through it. But now the leather is actually bonded with some sort of polymer, and that improves the structure and preserves the leather. So like it'll tolerate, wider ranges in moisture and temperature, and that's what they use apparently in automotive seats that were made out of leather. So, but yeah, so maybe similar process, chemically altering the tissue to give it different characteristics or whatever. Yeah.
All right.
Hey, I got a question. If we finished with that for Harold, Harold's got this really cool icon thing or surround around his image that's like a circuit board traces animated. How do you do that?
I'm using what you're watching is me trying to improve my Twitch stream, and this is called an overlay, and it's an animated. Let me back the way up. For the longest time, everything that you guys have been seeing here, it's been me doing hand drawing some things and throwing some lower thirds and stuff, and just overlaying all kinds of stuff. So, I've had this artwork for almost, I don't know, probably 6-8 months now, maybe even longer. And it cost me $25 from a site that's out there, and they have stream things. I forget which site it is. I can go look it up if you want me to. But they've got a bunch of them out there, and what you're looking for is OBS stream overlays. And there's about a bazillion of them. You can spend $100 or you can spend $25 like I did, and you get a whole bunch of different stuff. And what I'm doing is I'm setting up OBS to do a couple things. For instance, one of the things that came with the string is my starting screen. So you guys are seeing that now, and I even got it queued up. There's a little bit of music now going in there. So I play this when I start. And I've also got DMCA free music as well. Like I'm trying to be like more professional and look like I know what I'm doing, but we all know better than that. What you're seeing, what I'm doing is I went through the layout, picked out the sections that I want, and for instance, what I'm looking at right now is I'm making my desktop. So I've got my desktop thing, and you'll see me move it a little bit. And what I'm doing is now using that overlay to overlay on top all of my pictures. And so what I can do, that's about good for the moment. And this is part of the OBS thing that Carl was going through with us a while ago. And so now that I have that, and I found a way I can make it even slicker. For instance, so now I can go from me to my desktop, and I'm going to go through and create a scene to do each one of these for right now to switch between them. And then when I switch between them, I can have fade effects and a few other things, so it's more of a produced looking sort of thing.
Cool. Yeah, I did try the OBS thing that Carl did the tutorial on, and thanks for the tutorial, Carl. But it turns out that Linux has some issues where it won't display many kinds of screens. Like it won't display draw IO, and it'll display web pages, but not. It's sort of random which screens it will and won't display. But a lot of apps just won't project with the OBS camera, which is unfortunate.
Yeah, it depends on the graphic technology usually. Like for instance, for the longest time, you couldn't do a screen grab on Windows 10 unless you use their stuff. Because, well, not necessarily their stuff. If something was written in UWP and not native Windows, it used a different sandboxed up graphics mechanism, and you had to jump through hoops to make that screen capture work for you. So they've since changed that and updated that and that kind of stuff. It depends on how it's drawn to the screen. Because I mean, you'd think, well, it goes to the screen and gets the bits, and that's normally not how those things do that. What they do is there is a kind of a shadow. This is going to be not exactly right. There's in the buffer before you actually see the screen. There's a memory footprint of this, and depending upon which section and which and you have a graphic device that owns the memory that it's about to display, and the computer comes along and displays, hey, program Y, I need your display. Oh, here you go, and throws it up there and puts it in the right place effectively. And depending upon where that thing is in the place, sometimes it has access to that memory and doesn't. So that's maybe what you're seeing there, Paul, is something along those lines, because they're using some feature that the way that feature has to do what it doesn't give you the normal access path to go grab the screen to display it. I bet that's what's happening. Something along those lines.
It's a Linux specific problem, and it's widespread descriptions of it on the web, and everyone's saying, why the heck doesn't this work? And no one's
and it should. And you're right, it probably should, right?
Yeah. Thanks, Harold, for that explanation.
Hey, not a problem.
I had an Oak Delight question. I've gotten it to work on my Windows 10 machine without any issues. It flew through the install, and I could do the demos and that kind of stuff. Not so on my Windows 11 machine, and I wondered if anybody else had experienced that. No issue?
Say that again.
I ran and did all the installs for Windows 10 on an older laptop. It installed fine. I could run the demos and all that stuff. But I tried it on my newer laptop, which is Windows 11, and it looks like it tries to start. There's a like a command line kind of window that opens up, and I can see a few things, but then it gets rid of it. So I can't, it's like, I have to do it like multiple times to see what's in the window, because I can't get the window to stay there.
Sounds like a driver problem.
It could be, yeah. I wondered if anybody else experienced.
So is this upgrading from Windows 10 to Windows 11, or?
No, I have two laptops, one with Windows 10. It installed fine on. The other one with Windows 11, it doesn't seem to install correctly.
Yeah, they made a bunch of changes about how some of that stuff works, right? And so
yeah,
that's probably what you're seeing.
Okay.
Yeah, work, how you interact with the screen, a whole bunch of junk like that.
Mm-hmm. Yeah, I know. A lot of the it seems like a lot of the tasks or windows are like suspended if for like an eco mode, so they consume less power apparently. I don't know if something like that's going on, but one of the complaints that I saw in there is that my USB speed is slow, but it's USB 3, so I don't know if that's been throttled back to conserve power and it's not working at USB 3 speeds or something. I don't know. But,
could be power.
Yeah. Doug, did you say you had an issue with the amount of power the thing drew, that you wanted to get the Y cable?
Well, okay. Obviously on Windows 10, I had no problem at all. Or otherwise, if I just plugged it into a USB 3 port, it seemed to work without any additional power. If I on a Pi 4, if I had a SD card, it worked with it worked fine. But if I put in a solid state drive,
SSD,
it didn't work. It would brown out.
Oh, okay.
Yes. Okay. So on a Pi 4 board, it should work, but you're going to be pretty close. You know, if you're doing other things or have other things hooked to your Pi 4, you might have a problem if
Yeah.
they're power hungry.
Yeah.
But I was wondering, just for grins, one thing you might try, Ray, and I don't know, this is kind of off the wall, but you might want to run it in admin mode, see if that makes any difference.
Yeah, I did the install that way.
Okay.
And it seemed
But
like
when you run the program, do you run it in admin mode?
I thought I tried that, but I can check out and make
Okay,
sure.
I'm just saying, I'm trying to think
Yeah.
of, I mean, like if it's a driver, you're pretty much squirreled until somebody puts a new driver.
Oh, God. Oh well.
But I mean, I definitely would go ask that question on their forum.
Okay. Yeah.
OpenCV, and because
Yeah.
you know,
Yeah.
everybody's
You
gonna
know,
have,
there weren't.
everybody's gonna go to Windows 11 pretty soon.
Yeah.
Not me.
There's going to be
Well,
something else.
I
back
mean,
there.
I bet if you
Not
buy a
good.
new computer, Pat, you'll have a Win 11. So it's really when you're going to buy a new computer. And in my case, I don't, you know, I'll probably won't, since I'm pretty cheap, I probably won't buy a new desktop until Win 10 finally dies. I forget when it is. It's a couple years from now.
You
I'm
buy
still using
2020
Windows
and you're
7
loading
on
the
some
boot drive.
virtual machines.
Hmm?
I still use
Well,
Windows 7 on virtual machines because the
that.
software won't run on Windows 10 very well. And the only reason I have a Windows, I'm on a Linux machine right now, one of my laptops, but I have a Windows machine that I use for my part-time work, and that's it. Aside from that, I really don't have any Windows machines at home.
See, I'm just the opposite. The only Linux machines I have are the Pi 4s, and that since we do so much stuff in Linux, it does take everything I do takes everything a little longer because
The rule of thumb is that every other Windows release sucks. All right. So if you're happy with
that's
Windows 10, hang on to Windows 10 as long as you possibly can, because they'll find something wrong with Windows 11.
Yeah.
It's
Something
like when a
they're
company
liable for.
changes hands, no matter how bad you think upper management is, with the new management coming in, it'll get worse.
Well, Windows 8 was a total disaster. People hated it, and they had to come out with 8.1.
But you know, I remember living with Windows XP for how many? I mean, a decade or more. And then actually, I don't know how many machines I actually upgraded from XP to 7, and it went pretty well. It was impressive.
I've been running Linux since 2001 or 2002, full time.
Well, I think with Windows 8, they kind of got a little too full of themselves. They're like, let's change something just because we can. Just we'll make it look different. We'll make the whole desktop look different and force people to relearn the entire operating system just because we can. Just because you're not using Windows right, here's the right way to use it.
Yeah, they paid for that.
So as long as we're rendering opinions, my opinion is that Windows wasted a whole lot of time trying to beat Apple at being Apple when they had 90% of the market share. I don't know why they did that. It cost them a tremendous amount of market share, and they find themselves in their current dilemma.
Yeah.
All I can tell you about that is go look up Microsoft's history of their stock price right now. In the last year and a half, it's gone from like 100 and something to 250 something, I believe. So I mean, it's not like they're hurt too bad.
But they're
doing really good.
You know, all these tiles, all these little tiles that they started with Windows 8 and now Windows 10, they have these tiles, right? I don't even know. What's wrong with the desktop that you have? It's functional. It's functional, and I know how to use it. Don't put these tiles that are incredibly wasteful of space, for one thing, and don't really add much to the usefulness of the operating system.
I used to be with it, but then they changed what it was.
I will say this, but it seems to be something that happens to everybody because I love Raspbian, because it doesn't change much when I go from one to the next. But Ubuntu, man, those guys, couple of versions back, they went and they made some major change, and I just totally lost interest in them. I mean, I didn't even want to do it. I think it was 16.
Linux Mint.
Yeah.
And it's not bad. It's pretty good for most of the stuff I do.
Yeah. I mean, it's a good distribution. I'm not knocking the distribution. I'm just saying is for a beginner in Linux, it's just they were making it easier and easier and easier and easier, and then all of a sudden they just kind of made it harder. I don't know. So
I think it was after Hardy Heron that they started going sideways, trying to mimic. I don't know if it was Windows or what.
Yeah, it needed otherwise you used to be able to put it on old machines, and then all of a sudden the graphics changed so much that you couldn't put it on old machines.
So here's the thought, though. I mean, think about trying to teach somebody to use a computer who has never used a computer before, and then you will realize how much accumulated knowledge you have taken for granted.
Oh yeah.
In how to use that operating system. Mm-hmm. And when they come along and make radical changes like that, you're taking so much of your accumulated knowledge and tossing it out the window and demanding the users learn something new, learn something different, and that's costly.
I'm still mad that they went from tar-xvf to tar-xvf and complain at you that you put a dash in it now. Leave me alone. I like my dash. Leave me alone.
I think Windows was at its peak with 98 SE.
Yeah. SE, well, one thing that's really interesting, John, along your lines, is Photoshop. Photoshop, you can really see what a 1990 interface looks like. I mean, they have not changed. They got this little crappy toolbar on the side. Everything, you can't even make the screen get bigger and smaller by scrolling your mouse or anything. You have to go over and hit an icon and then go pounce, pounce, pounce to make it big, or alt pounce to make it small. I mean, and the reason they did it is exactly what you're saying. All those people that are experts in Photoshop, they don't want to lose all that knowledge that they've got. It's just, and they haven't done it
for the most part.
But
I think the people that are, I think the people that are in like the Photoshop, the Fusion 360, all those kinds of things that use it professionally and are into it and that kind of thing, they're going to do keyboard shortcuts, and they're going to, because all that, I mean, one of the speed ups I did for one of my clients was on Windows XP. He said it's now slow and doesn't work as fast as it did. So I said, okay, let me see if I can fix it. All I did was go in and turn off the animation for all the menus that would show up, so it just pop up instead of scrolling up and taking all that CPU time. And they're like, oh wow, it's faster, thanks. And I'm like, I didn't really change anything, but the perception was there, right? So all the people that are doing all the people that have all the control, the keyboard shortcuts and all that stuff, they're not even going to pay attention to all that noise that's on the graphical screen, because they're shortcutting everywhere because they're getting their job done. It's folks like me that search around for all that junk and go, oh, now they moved it over here. Now I got to go 2 levels deep to find the thing that I only used to go 1 level deep. Because if I knew the shortcut, I just hit the shortcut. I wouldn't care where it was.
Well, I think.
You remember that Apple joke where, and we moved the power button from here to here. Do you remember that one?
Well, I think the real value in changing an operating system would be, don't change something that already works. Give me something that you couldn't do before with the old operating system, and we'll do that the new way. That way you don't have to throw out the experience that you have with the operating system, and now you've got a new feature you've got something that you can do you couldn't do before, and you're going to go and use it, of course.
Okay, I want everybody to see that I have what little hair I do have is all gray. So when I'm telling all of you folks in the team that you have the get off my lawn syndrome, you have the get off my lawn syndrome. We're not the market that they're marketing this stuff to. So we just gotta try to suck it up. And I hate that, and I catch myself all the time because one of the things I'm doing is I'm interfacing with people that are building products and services for folks today that are 20 years old. And if I get too much into that, well, that's not how we did it before, then I'm probably thinking the wrong thing, because that's not who's paying the money for these things. Right?
That's probably true. That's probably true.
Yeah, it's the people they're marketing.
Good insight.
Who haven't built that knowledge up, who don't have to sacrifice.
Agreed. I mean, it's like kids today. I will guarantee you, if I took, now my laptop now has a touch screen on it, right? Has a touch screen on it. But if I were to take one of my laptops, like my other one my lab laptop doesn't, if I were to take that down into like a 10-year-old and have them to start doing anything, the first thing they're going to try to do is touch the screen and move stuff, because that's what they're used to. You know, I hate people touching my screen. Don't touch my screen. I'll get
Gets a lot of smudges on it, you know?
Yeah.
So I had to turn off my touch screen because it kept moving when I was working on every time I pointed to it.
I worked with a guy at it was E-Systems in the 80s, and he didn't have it. Of course, we didn't have touch screens back then. They were just starting to come out with them. But every time he would do something, he would put his fingers on the screen to point to his code or to point some documentation. And eventually he wouldn't clean it, and eventually the screen was real blurry because it had all his finger grease on it and all his fingerprints. It was horrible.
What the problem is I just gave that speech about get off my lawn. I'm about to talk something. Back in the day when they had the green screens, and that was the only color you really had, basically, they came out with a series of screens to reduce glare. And literally, it wasn't a matte screen. It was like a bunch of little pyramids all over it. So there were crevices down in it all. So if you ever touched that screen with a wet thing, you were screwed for a very long time. You're not getting it out of there. You're not. Luckily, those things didn't last too long.
See, that's why we have to watch it, because, I mean, we're on the other side of 30. If we were on the other side of 30, it'd be, oh, that's an old idea. That's from somebody over 30. So
so it can't be any good. Right?
It can't be any good. Have to do something different. Which brings us to the other thing, is that I think we're losing people. It's getting past people's bedtime.
Oh, yeah. It's always fun to gripe.
It is always fun to gripe.
And so, anyway, what you guys have seen is the preview of what my Twitch stream is going to look like starting tomorrow night. It's not finished. I want to do a lower third that's animated, and I've got stuff to do it. I just hadn't played enough with it to get a thing that I like to pop things up and do stuff. And I got music that started, maybe a little professional, more than just throwing some crap on the screen. For instance, maybe a little bit more.
Well, I guess I should bail. My cat's here telling me I'm spending too much time in front of the computer, not paying attention to him. So
my screen's telling me it's too much screen time. It says look away, focus on something further away for a while. Okay. All right, guys. You guys have a great night, great week, and we'll catch you all.
Take care
On the other side.
Bye-bye.